Hello, good morning, ladies and gentlemen. Hope everyone is safe and good. My name is Haripriya. I am working as a software engineer in Confab Technologies. Along with us, we have our co host Tahir.
Hello all, my name is Muhammad Abu Tahir. I work as a software engineer at Confab Technologies LLP. My work is predominantly based on serverless using AWS native services. This is a great day and we are very excited and honored to have you all today. A very warm welcome to you all. So this is track 2. We have another track going on in parallel, that is track 1. The link for the track 1 is given in the description. Please feel free to check it out, and let's make our day productive by listening to the amazing sessions by all these AWS experts. I hope you enjoyed listening to Rohini's keynote on the Cloud Odyssey. That was very amazing, and I am fully excited and loaded for the upcoming sessions. So I expect you to be excited as well, and we have one more small request. People, please put your name and the place from where you come in the chat box or in the comment section below, because this will really help us and motivate us to keep bringing these kind of conferences in the near future. Thank you so much. I welcome you again. And Haripriya, I guess you can now walk us through what is lined up for today.
Yeah, sure. Alright, everyone. In track 2, we have 7 sessions and quizzes as part of tournament. At the end of each session, there is a quiz. At the end of the day, we will be announcing top 20 winners of the tournament. So please stay tuned and check the tournament leaderboard from time to time. Also, please feel free to post your valuable feedback, doubts, and queries in the YouTube chat box. Our team is standby to answer all of them. Don't forget to share in social media about your good time in learning from all these sessions. Make sure you use hashtag ACD2022. There are prizes for best shares and best tweets. So, without any further delay, let's dive into the sessions of track 2. Let us invite our first speaker, Ilan Ganeshamurthy. Ilan is a technology leader and a great IT professional with many years of experience in software solutions. He is currently working as principal architect in digital innovation team focused on cloud and NLP. Ilan is speaking about build AI ML apps without data science, statistics, or ML algorithm expertise using AWS AI Service. Welcome, Ilan, to the stage. We are very eagerly looking to learn more from this exciting topic. Over to you.
Hey, good morning, all, and good morning, good evening, people everywhere staying. Okay, so welcome to my session. So, building smart apps with data science starts our ML algorithm experts. I'm very excited to be with you all today, and this is our third edition of uh, this is our third edition of a virtual conference. And okay, so in this session, what we will be seeing is, so today there is a kind of a myth which you will be seeing it most of the time. If you want to do a ML based algorithm, if you want to do ML based project or AML based driven project, you need to be an expert in data science, or you need to know stats, you need to know multiple ML algorithm. Then only you can kickstart your ML journey at all. Otherwise, it's not possible to build. But but the truth is that's not the case. So there are services which we can use and build one of the state of the art best projects, ML based projects, without having this ML expertise or without having data science or statistics knowledge. So that's what we'll be going to see. So this is more about how AWS is democratizing AI, where people can build some of the very advanced ML powered application. So getting into this, this is some of, I want to introduce myself. So my name is Ilan Ganesha Murthy, and you can shortly call me Ilan. And I'm Alexa Champion, and I lead conversation AI initiatives in Kyoto Every. And I focus on emerging technologies, predominantly focus on the emerging technologies in terms of cloud native architecture, AML or NLP. And I'm being an Scrum mentor for 2019 to 2021, and I'm a community leader and Chennai and a co-organizer of AWS Community, Chennai co-organizer. Yeah, so I do a lot of work in conversation AI initiatives, and I have around 8 years of experience working in multi-cloud technologies. And let's get into this. So I work for company Toyota Every. So Toyota, now I'm part of Toyota Every India, which is a global, Toyota Every is a global group which is spread across globe, and they have headquarters in Norway, Nordic, and we have around 4 billion of revenue, 25,000, 24,000 people spread across the globe with 10,000 customer. Okay, and we are number one IT service provider in Nordic, which comprises Swedish, Sweden, Norway, and Finland, kind of thing. Yeah, getting to the next one. So this one next for 40 minutes, which we will be looking into it. So predominantly the agenda for next 40 minutes. So first we'll get into the challenges related to ML introduction. Okay, first we'll get into challenges of why it is difficult for a person to go and build some kind of a ML projects, and we'll see some introduction about ML. Okay, and then how AWS is simplifying it. So what is an AWS answer for the ML challenges faced by regular developer? So that we'll look into it, and then we will focus on the few services which AWS is offering. So service like Text-Track, which helps you to convert from convert the a scanned image to text, and then we look into service component service, and then the augmented AI. So these are some of the services which will go a little bit deep into it, and I'll showcase you how it is very easy for us to go and build some kind of an ML based and smart app which were there. Okay, and moreover, I'll be focusing on the use cases. That's a predominantly. So there is no point we just learn the technology, but as we all know, the technology should drive the business. Technology should power the business. So we'll focus on the use cases, which helps in building it. And some of the use cases which I'll be focusing is intelligent document processing, and then AI powered chatbot. By the key thing is we'll build this use case by using the AI services, which is provided by AI, and there is no need for you to know any of the ML techniques of it. Yeah, that's what the agenda is. And let's get into the, let's open the screen and get into the introduction. Yeah, specifically, if you look into, first, let's see from the classical programming, which we regular devs, which we are doing. Okay, so predominantly classical programming is about business gives and tells what is the rules of it, and we write a program, and end of the day, what happens is to the computer, we feed the program and we feed the data, and eventually we get the result. So that's, if you look into, it's like peeling the onion. If you remove all the layers, you see that's what we do day in, day out kind of thing. We write a program and we give the data and to the computer, and it gives that answer to it. We invert this in the ML. What happens in ML is we invert this in the ML. So we start with the answer when ML is about training the computer to write a program. So when we want to train a computer to write a program, what we do is we have the data with us. So we know what is an input, what is a correct answer for it, and then we give the data to the computer. So computer does some kind of a magic, and it gives you program for it. So end of the day, what really happens here is, so ML creates a program for us, and then at the time of inference, at the time of say in production, we run that particular program. So in short summary, what really happens here is in classical programming, human writes the program, okay, by keeping the rules. But whereas in the machine learning side of it, the machine creates the program for us. It looks into the lots and lots of data. For example, take the case of if you want to identify, is it a cat or is it a fruit as a mango fruit? You give lots and lots of data to the computer, and it does some kind of statistics, and then it creates a program. So that's a key difference for between the classical program and ML side of it. And one more thing which I wanted to drive here is, as you know, most of the people, they use the term AI, ML, DL, which stands for deep learning, in an interchangeable manner. But it's not an interchangeable kind of thing. If you look into it, how it is organized is, so in broader sense, if AI is something like you're automating the cognitive workload. So whatever the kind of a cognitive workload which is performed by a human, we go and automate that specific thing. So that's about the broader section of AI of it. So machine learning is something which is a subsection in that specific AI kind of thing. So it's not a AI is not completely equivalent to machine learning, but machine learning is something about a subsection in the specific AI side of it. So in past, we were writing a lot of programs in AI programs without machine learning also. Take the case of chess, or you take the case of decision system, which were very predominantly famous in 90s and in 2000 also. So those are the AI kind of programs which we wrote without having a machine learning. So machine learning actually picked up in later part of 2000 and then early 2010 and onwards. Okay, so machine learning is about machine learns and performs the artificial intelligence side of it. And coming to that subsection of again in the machine learning, very famous now it's happening. So the whole advancement, whatever you're seeing in machine learning, whatever it's happening, and so all those things is triggered by the deep learning side of the machine learning of it. Okay, then deep learning is again a part of a machine learning. And moreover, now you will see a lot of things happening in the artificial intelligence and predominantly with natural language processing. So natural language processing is something like it's a combination of artificial intelligence, machine learning, and deep learning. It uses rule-based directly, which is part of artificial intelligence, and it does some kind of machine learning, and it kinds of deep learning side of it. So this is a broader. So it's not a terms are interchangeable. It's all just like a subsection of it. Yeah. Before getting into it, I just wanted to give you some types of machine learning, what we see here. Okay. So predominantly when we see machine learning, it all starts with the supervised learning. So that's how initially it has been started. So supervised learning, then unsupervised, semi-supervised, and reinforcement. These are major four categories of it. So in supervised is nothing that what it does is typically you teach the computer by having the labeled data. So label data is nothing something which has both input and output pair kind of thing. For example, when you want to teach the computer to tell, okay, this is a cat image, and you have a label attached with a cat kind of thing. And if you want to teach the computer, say the spam detection, so you give a spam email and tell the computer this is a spam. This is an email, this is a not spam kind of thing. So primarily it is comes with a pair input and corresponding output of it. And then it has subsection of continuous and categorical kind of thing. So target variable or nothing in machine learning, we call output values as a fancily, we call them as a target label. So continuous is something like, which is a continuous number of it. So if you want to predict a house price, or if you want to predict a weather, this is a continuous number. So those we call continuous target label problem, which are nothing like a regression in machine learning terminology. Then we have categorical kind of things. Categorical is yes or no, or some kind of a category. It is not just binary. It can be even 10 different types of category to tell, okay, this is a mail is a spam or not spam. Okay, so this image, is it a cat, dog, or cheetah, or whatever kind of thing. There's a specific kind of category. This is called a classification side of it. So those are the major subcategory as far as supervised learning is concerned, and some of examples which we call it as a stock price. Like as we know, stock price prediction is continuous in nature, then it becomes a continuous target label. And like a spam detection, it's like yes or no, this spam or not spam kind of thing, or he has some disease, he didn't have some disease. So those are kind of a classification of it. Coming back to unsupervised, so as I mentioned, in supervised we have a both input and output, but in unsupervised you just throw the data to the computer. Doesn't have any kind of a label. It doesn't have output. So only input data are there. So computer by itself, by algorithm machine learns by itself, okay, to group certain kind of data, to cluster something by looking into similarity side of it. Okay, you have 10,000 records. So in this 1,000 is of certain section of group. It can be based on the size, or can be based on the color, or some kind of a grouping based on characteristics. So that's called clustering kind of thing. So take the case of customer segmentation as one example. You give say 10,000 records of transaction happen. So based on the purchasing habit of it, it segments into different. Okay, this might be a purchase based on Gen Z. This might be based on certain kind of a certain segment of customer. That's about unsupervised. Then we go about semi-supervised in nature. So semi-supervised is something like that. Okay, again, it is about it's a mixture of both supervised and unsupervised. So what it means is it has both labeled data and unlabeled data. What it means here is, so creating a labeled data is very tough task in as far as the machine learning is concerned. So people, what they do is they have a, say if they have 10,000 records, they give only 1,000 records as a labeled kind of a data, and remaining 9,000 major portion will be unlabeled data, and it does some kind of a magic and does the learning aspect of it. That's about the semi-supervised. And then we have a reinforcement learning. So typically it's always not to teach the computer with telling that this is a label or this thing. So what we do in this is we ask computer to put it, it's like a software agent which works in the environment and allow you to take a decision. We allow computer to take a decision, and if it is a right, we reward it, and if it is a wrong, we punish it. So it's like a carrot and stick kind of thing. So assume you are making a robot and you are asking robot to walk. If it walks correctly, we reward it, we just give the carrot, and in case if it flutters, if it falls, then immediately we punish it, okay, with some sort of this thing. It's like a stick kind of thing. So by doing this each and every time, we give feedback immediately and it learns, then it improves on it. So like chess playing, like created by take the case like a program like Go, which has been famously created by DeepMind kind of company. So those all falls under reinforcement learning category. So these are the broader classification always will happen in the terms of machine learning side of it. Yeah, and typically what happens in the terms of it, so why it is difficult, that's what it is there. So predominantly it's very challenging for people to go and create a ML. So only it is a forte of ML engineers or data scientists to go and create some kind of a data science based application. The reason is the particularly workflow itself is that. So I'll tell what's happened in a typical ML project workflow. So what happens is business comes with the kind of a requirement for us. So immediately we go and frame into business ML problem. So once ML problem is framed, so what we do is we go and collect some kind of a data. So we go and collect the data, domain data, do it. We do a data cleansing. Then there is some kind of thing called future engineering people do. That's very important. So major 70% of work will be all towards doing this particular task itself, identifying the right data, cleaning it, and then creating a specific future engineering side of it. Then you go and choose a specific ML algorithm that comes to that. So based on the problem as mentioned earlier, like unsupervised, supervised. So there are a lot of classification it, and based on the problem which we frame, so we will go and choose some kind of algorithm. We either choose random forest, k-means cluster. So that kind of algorithm we will choose. Then what we do is we set up an environment, we take the data and we choose the algorithm, then we start training side of it. So this is about training and tuning side of it. When we train, it is not going to work in a first time. So we do a lot of iterations. In machine learning term, we call epochs. We do a lot of epochs kind of thing. Okay. So then each and every time we train and tune. If there is first it may start with 60% of accuracy. Then we make it improve, then that's called a train, debug, and tune the models, and eventually we get some kind of accuracy. And this is about managing the training side of it. And then once we have that trained model, we come to the inference stage, which is a production kind of thing. That's where we deploy and manage it. So this is again about deploying to production. We take the model, we make it like an API based, then we do it, and then we monitor the model for its performance to see if it's performing rightly or not. And moreover, the model was created earlier, so we need to see its result also. We need to validate the prediction, is it making right or wrong. So here we have something like a drift will happening, like data drift, okay, or it can be kind of say data drift might happen, or it can be model drift might happen. So we look into all those things and eventually we do this thing. So this is what typically you want to do a ML based production grade project if you want to start from scratch. So those are very difficult for even data science and machine learning engineers, and forget how regular devs can do those things of it. So now we have AWS comes into the picture. So this is where AWS comes into the picture. They completely and democratizes. Once they release that AI ML at early stage, so their main objective was how we can democratize AI so all people can do, regular devs can start doing AML, and it is not just forte of only the ML or AI data scientist. So they came with the method to put machine learning in the hands of every developer, and it's it's pretty much success kind of thing, we would say. And now it's in 2022. We see a lot of people are doing it. In fact, I'm a regular dev, so I come from a regular development background. Okay, I do a lot of NLP based project by leveraging the AWS AI services, and it is very difficult even for the seasoned data scientists or ML engineers to bring in to develop this kind of a NLP based project, which I do with AI services of it. Yeah. And coming to this, so this is how AWS organized it. So they started with it's like how we see typically in cloud, we have IaaS, PaaS, SaaS kind of environment. So you can iterate, I mean, you can relate to that. So this is like a SaaS services, AA services of it. Okay, it's application service. It's just like calling an API based kind of thing. If you wanted to do some kind of a image recognition, which we call computer vision, it's a very complicated problem. You just call some API. We call Amazon recognition, and you call the specific API of it. So even in text, you want to do process a text and identify some kind of intent or entity in it, or to translate, you just call some API and you get it. So this is about it. Just like SaaS services, you call REST services. Anybody can do. Okay, and then we have a ML service, which is nothing like a PaaS services kind of thing. Okay, so typically this is a SageMaker, which is a very famous in this. So there is no people who worked on the ML. This is for the person who are like a ML developer. So they work in the Jupyter notebook, they work on the IDE, and they build their data science project. So this is for them, the ML services. So this is typically for the ML developer. So this ML framework, typically in the IA side of it. So this is for the kind of a ML practitioner who are doing a day in, day out kind of thing. So they are doing a regular day in, day out kind of thing. It is for them. So they can use TensorFlow, they can use MXNet, and that particular kind of thing. So in a short, if you want to use AI service, if I want to do an image recognition kind of a problem, which is a computer vision, I can go with the recognition and I can call it. Say if it is an NLP world, if I want to use speech, I want to convert from speech to text, then immediately I can use service like transcript. You stream an audio and it will convert into a text, and you can do some activity around it. If you want to do reverse, you want to convert text to speech, then you can do a poly side of it. So similarly, for example, you want to translate from one language to other language, then we can use a translate kind of a service, and text track, which we'll be seeing it. Okay, and if you want to add intelligent search for your application, you just use a Kendra. So you put the data, it will start working on top of it. If you have forecasting kind of a problem, you can just start using the Amazon forecast kind of the thing. Okay, and then there, if we are building a chatbot, okay, building a chatbot from scratch is very difficult. You use a Lex, and you can just by calling an API, you have a full working very high grade kind of an application. This is about AI services, and this is where the democratization of AI happens. So this is where our regular devs, we can go and use it and build a high grade application very quickly of it. Yeah, let's get into this. So let's get into, I want to take one use case and go to it. So typically in industry, document processing is a very standard use case. So if you look into pre-ML, in any place, if you go, the document processing will be a standard kind of thing. You'll have a scanned copy of a document where you want to write some program to identify, to get an insight. So that's a standard in the any kind of enterprise. So far they were doing it manually. So if you're doing manual kind of thing in earlier days, it was very expensive and time consuming. You have a paperwork and you identify, read it, and then type it. And those are the manual processing, very expensive and time consuming. And then they started using optical character recognition. You scan the document, then you feed the scanned copy to the computer, then it does the job. You get a flat bag of words. So typically you get a bag of words kind of thing. So like a paragraph of text, and it has its own drawback. It's a limited because it's a accuracy, it's limited. Or if the table structure, it is, if you have assume you have form, you have table structure, you have only chunk of text will be there. Okay, but you won't see much things in this. That's about some of the problem with optical character recognition side of it. Then you have rule based and template based. So if document is not adhering to some rules, then immediately it will become brittle and it will break kind of thing, and it's very difficult to maintain also. These are some of the challenges which you want to do document processing in pre-ML area. And let's see the steps what you will do. It's typically about extracting the text from the document. So it can be an either OCR based or even can be manual based also. And you want to get insight from it. So once you extract a text, you want to get insight. Say you want to identify what is the company name mentioned in it. If it is a medical document, what is a patient name? What is a patient ID? Or what is a medicine name, disease name, like that. Those are the sum of insight you want to get it. So once you get the insight, so probably you will have a human will come and see is it correct or wrong. That is the kind of thing which will come to the picture. So if you automate this and you do it in a AWS era, so this is how it will be. So for extracting the text, you start with the Amazon Textract, which helps you to extract text from the scanned image or PDF copy of it. Then you have a get insight from that, okay, extractor, which is nothing the comprehend, where you get a named NER kind of thing, entities, okay, or it relationship and multiple things. And once you have a human in loop which comes to the picture, because you can't trust completely 100%, okay, it has directed the correct medicine name, it has directed the correct disease name. So that's how the human comes into the picture. We have Amazon has some series called augmented A to I. So human in loop, which comes and helps to resolve the things of it. Okay. Yeah. So let's get into the text track side of it. What we do in the text track side of it. Let's take the case of a text track feature. Okay. So once what is it? So typically, as I mentioned to you, it helps in extracting and analyzing the text data from your PDF file. So PDF file will be multiple types. There are PDF file, just a scanned copy of it. It's like an image. It can be a JPEG. It contains only image text of it. Okay, you can't control C and do anything. So you send this information to text track. It extracts and analyzes the text. That's like about it. So once it extracts, it can be a raw text also, or it can extract a form. So you have some form, physical form. Once you scan it and give it, it can extract the form and can keep a relationship of. So same thing like a table. You have assume we have table structure data. It extracts a table and gives. And not only it's type data, it can even do handwriting extraction also. That's the kind of thing. And this is a key thing is it just not extract the data, it maintains a relationship also. For example, if it is a table, it knows this is a table object. These are the columns like a name, age, employee ID, and what is related, like a JavaScript object which it maintains. Same thing for form. If it is a name, it knows, okay, it's a first name, last name. It maintains a relationship side of it. So that's a key advantage feature of the one of the our text track side of it. And moreover, by inbuilt, you start just using API. It's already trained for multiple types of documents. Take the case invoice or receipt or financial document or medical insurance document, driver license. It just for all those things. And very importantly, it is based on the deep learning technology which is used by Amazon CV team, computer vision team. Because as you know, Amazon has a very big computer vision team and they're doing for a lot of years. So it is based on the specific algorithm. So we can expect such a good quality from it. That's about it. So let's see the advantage of it when I wanted to use it. So when you start using it immediately, say you want to build an application and you wanted to add some kind of a text feature, integrate text document detection or something to your application, just like that by integrating it into your application, you get the specific thing. Okay. And moreover, whenever it extracts any text, take the case it extracts a document or a table or form, it always comes with a confidence score of it. It tells, okay, I'm confident with 90%, I'm confident only with 60% kind of thing. So based on the confidence score, we can take the informed decision. So it is not like that, okay, it is yes or no, and we will be left in a lurch kind of thing. But in this case, instead of that, you can take an informed decision based on this confidence score of it. And again, you can add human review to the workflow. So we can add a human review to the workflow, as I mentioned to you earlier. So based on the confidence score, we can decide to go with it or not. Okay, and you can scale for thousands of documents, and this helps in making accelerated decision making. Okay, and this is a very key thing of it. As mentioned earlier, it's addresses for different types of document. There is no need of template or no need of configuration. You just call API and you can start using it. Okay. So it does for both online and as well as a kind of a batch processing in the nature of it. And typically comes with low cost pay as you go, which is a typical cloud-based SaaS service model which we have in the AWS side of it. This is about advantages. So this is a picture which you can visualize if you want to do it. So different types of financial documents we can do it. So if you have healthcare document which might be in different format, you can start utilizing for it. Okay. And say I was mentioning about relationship. So suppose in your document there is a section which contains name, which has first name, middle name, last name, first name, middle name, last name kind of thing change. So it will maintain relationship. It will give a name object with this like a key value pair, like first Jane, middle Lauren, last John. It's like typical JSON object which you will be getting it. And data type also, if it just like no kind of thing, it will give you proper data type. If it is an integer, it will give proper integer number data type, string data type. Even if it distorted in multiple ways, it will have it. Say, and there's a variation also. Take the case in US, there is a W2 form which will be there. There will multiple variation of the form. So for all different variation, it will work. There is no configuration for it required kind of thing. And this is something about, again, I just want to see how in a typically scanned copy of document, you'll have a table like this. But even for the table like this, it will clearly extract the text. Okay. And if it is a form kind of thing, it will have a key value pair, it will have confidence score, those kind of things which it will maintain up. These are some of the advantages when we use the text track services of it. Now, if you go and look into comprehend, so suppose you want to build some NLP based services. Building NLP based service is very challenging. You need to know a lot of things. You need to say, suppose you want to use NLTK library, or you want to use something from Stanford Stanza libraries to do a NLP operation. Instead of that, you just come here and start using the comprehend service of it. So what it does here is, in short summary, it's a fully managed service. Okay, it's fully managed and continuously trained service, which helps you to extract or discover insight and relationship in text. It's typically, in short summary, it's about NLP service. Once you read it, you can get insight from the document and you can get relationship also. Okay. And as I mentioned to you, it's about NLP's kind of NLP service. Okay. And moreover, this has both pre-trained and as well as a custom of it. Okay. So what it means by pre-trained is you can just use the API and you can do some kind of a, say, I want to do the problem of entity recognition. So take the case, I want to do problem of entity recognition. So suppose if I have a text. Okay, so today I attended AWS Community Day. I really liked it. So if we give this particular text, so it recognizes the AWS as a company. Okay, it recognizes Community Day, and even if we tell that the month and year, it will completely recognize. This is about the entity recognition of it. So it does the recognition of it. And if you give a text, say where you identify text, it contains like a patient name, patient ID, or SSN number. It will identify even the personal identifiable information side of it. Okay, and this is something about the classification side of it. Suppose you are working in insurance industry and you give a document and you do custom classification training. And the training is just give a different type of a document and you trained it. So now you can identify, okay, this is related to motor insurance or this is related to fire insurance kind of thing. Okay, or take the case of customer service. Okay, this call is specifically related to HR customer support. This call is specifically related to IT support. So those kind of classification which we can do, and it does a language, dominant language detection. It can identify French, it can identify English, German. So there are multiple languages which it can identify of it. So when it comes to entity, not only entity, it can identify key phrases in the document also. And moreover, it can identify overall sentiment of a document. So you give a document, it identifies the overall sentiment of it. And then kind of called topic, we call it the topic cluster, topic identification. You throw a set of document, it can tell, okay, these documents are related to sport articles, or this documents are related to, say, some kind of political thing. So you can customize this for your domain also. Okay. So those are some of the things which you will be getting the benefit from the day zero when you start utilizing the comprehend side of it. There is no need for you to customize anything to provide this. And moreover, all those things comes with a confidence score, as I mentioned to you earlier. So where you can decide, okay, this data based on the confidence score, you can decide I can automate it or semi-automated by using the human in loop. Yeah, this is some of the advantage which I want to build. So this is a state of the art kind of thing. So you get the state of the art advantage of kind of thing. If you want to build by yourself, it's very difficult even for the machine learning expert or the data scientist person to build this kind of a performance by using the deep learning, whatever build it on top of, build it by Amazon for exposing this service. Okay, it integrated powerful NLP feature into your application, and and what it does is you can use a text track, and you can just give comprehend both to form a perfect pipeline, which I'll be showcasing also. And as I mentioned, you can classify the document for the multiple purposes, which I mentioned in my earlier slide of it. And you can analyze the document for custom entities. You suppose you have business, insurance will have a typical thing, and medical industry will have a typical, you have medicine names, disease name. So you can train it, and you can extract the custom entities or domain terms related to this. And typically it's about it gives advantage like low cost and pay as you go, and it can scale for thousands of documents. There is no need for you to maintain it. So it's Amazon is maintaining it. You'll get the very advantage, and go to market also will be speed of it. So this advantage is what you get in terms of this one. Okay. So then the case of augmented AI. So this is a kind of service which we'll be leveraging it. So here what it happens here is what Amazon typically does is, so it's about a human in loop. So what actually it happens is, so as I mentioned to you, when you use some service, it give confidence score. We don't know what to do. It has to be semi-automated kind of thing. That's where the human in loops comes into the picture. So human decides, okay, I can go with it or not, or he gives the feedback to the algorithm and the model telling that, okay, whatever detected is wrong, correct it kind of thing. That's how human in loop comes into the picture. So that is where the A2A services, Amazon augmented AI service comes to the picture of it. So you can just include in your various flow, extraction flow, you can include in a various flow of it. Okay, and you can integrate to the custom model also. There is some service called Mechanical Turk and all in Amazon. You can leverage those services, and you can use it also. And more importantly, you can use this for a content moderation purpose. Suppose you want to do content moderation in addition to automation, you want to bring in the human agent to do the content moderation, where we can do for the content moderation of text extraction. These are some of the features of the Amazon augmented AI. So this is a typically workflow which happens when you're using a Amazon augmented AI. Yeah, this is a typical workflow when we use the Amazon augmented AI. Okay, so let's take the case of the client application. Typically, we have a client application which sends the data. AI service detects it. Okay, and then what happens is, if it is a confidence score, it goes to this one. It goes to high confidence score. It directly gets into this application. Okay, or if it is a low confidence, you will be able to detect the specific kind of thing. Okay. Yeah, so that's
Dylan,
about,
sorry
yeah,
to interrupt.
yeah.
Yeah, we are running out of time, so
Okay, I'll just close it.
5 minutes ago.
Okay. Yeah, so this is the last slide which I'll get into it. Yeah. So this is a typically last slide which I wanted to touch upon this one. Okay, so what happens here is, so this is a high level overall architecture of it. So where it happens is, so you give a financial document. Okay, you give a financial document to it. So it does a extracts that information and does a data extraction part of it. Okay, then you give the text, and computer identifies a named entity recognition, and other side of it, it enters a named entity recognition. Okay, and you can use it for a multiple use case. Once it identifies it, for example, you want to do indexing or searching. Okay, so typically you can do for indexing or searching, you can go ahead and use this particular type of it. Okay, and you can tag it with a named document. So I can go on later case, I can go and search for the specific document which it will be coming it. And if you want to do for compliance and control side of it, say if you have scanned copy of document, you want image in a specific format, image should be on right side of it, it's not on the left side. So those kind of things, compliance and control, which we can bring to the picture. And voice of customer analytics also. Suppose you have a lot of data, customer feedback, you give to this algorithm, use the service, you can do a customer analytics also. What it typically does is, so it reads it and it identifies it. Okay, this your customer is talking about specific product. Customer is happy, not only just happy or happy or unhappy, it talks about what kind of product. These are some of the customer analytics which we can do. So there are a lot of things which we can do by including the Amazon augmented AI, and as well as the kind of thing. Yeah, so that's about it. So this is some of advantages what you get by using intelligent document processing by using the AWS service of it. Yeah. So if you have, uh, this is a short, okay, sorry for it. Yeah, so I'm just done with my talk thing. So if you have any queries, you can connect with me in LinkedIn. And just before going, I just want to give one my view of how when you work in cloud. So most of the cloud in your work, so you should be like a tech consulting kind of thing, where you need to know a lot of topics in the cloud, because cloud is huge set of service. You need to know a lot of topic, and you need to be expert in one specific topic. So that's we call tech consulting kind of thing. So you need to have broader direction. So it's always good, as much as topic you learn from the high level perspective. So at the time of driving the real use case, you can provide the consulting and be an expert. So I just want to quote Thomas Huxley, which he mentioned it. So try to learn something about everything and everything about something. So like you need to be a broader kind of thing, horizontal, and you need to be vertical in specific topic. So you choose something and you expert on this. So all the best for the participants who are attending it, and we have great session lined up. So have a fantastic time. Thank you, Hari Priya.
Yeah, thank you, Ilan, so much for the interesting session. So I personally enjoyed the session a lot. And many of the attendees were asking about the slides. It will be good when you upload them in a Google Drive and share it with them.
Yeah.
And also for all the attendees, the whatever the YouTube is streaming will be always in the YouTube. So you can come back and also listen about this session and watch the slides from there. Yes, so many of our attendees have been enjoying a lot from this session. They were gaining much more knowledge. I'm mentioning thank you, Ilan. Okay, let us start the quiz for the day for this session. So the quiz link will be shared in the comment box, and also the QR scan will be displayed here. You can scan the QR code and go to the quiz hub for playing the quiz. The quiz will be started in 2 minutes so that you can scan the code, go to the quiz hub and sign up from there to play the quiz. So let us see, like only we have 10 participants. Let's wait for a couple of minutes more so that all the participants can join here. And we have 20 winners. We will be giving prizes for 20 winners for the whole tournament. The tournament will be included for all the quizzes of all the session based, and also there are two main quizzes that will be interact one. So one is after the lunch and one have been already ended. So always check the tournament leaderboard to latest updates. Okay, let us start our quiz. Okay, the question will be coming into one. I guess everyone will be able to see the quiz in their screens. The first question is, what is the core service user for chatbot development? recognition, Lex, Code Guru, fraud detector. I see most of the people have already attempted the question. The score for the quiz is based on the highest points as well as the lowest time. So the faster and the smarter wins the quiz. Let us check the stats. Okay, 48% of the people have got the right answer and 7 people have skipped. Okay, let us see. Please don't skip and answer something you know about the quiz. Okay, then jumping out for the next question. To use a pre-trained AI service as it is we require a lot of AML development experience, model turning knowledge, a lot of library data, none of the above. Come on, everyone. I can see most of the people haven't attempted the question, so you're running out of time. Yeah, the question have ended. Okay, let us check the stats for this question. Oh, 14% of the people have attempted for the correct answer. That's nice. Okay, let's jump for the other question. Text track is used to get insight NER from the document. Is it true or false? We have Anshit sit in the top, attempted all the 3 questions and all were right. We have Aishwarya Sood in second position and Nikhil in third position. Yeah, we are running out of time. Yeah, the question have been ended. Let us check the stats. Yeah, 12 participants have attempted the correct answer. Next, jump for the final question. Let us see if someone beats Anshit or not. The question is coming up. Now you are able to see the question on your screens. Amazon Poly is part of Vision Service, Forecasting Service, Speech Service, Development Service. Again, Anshit is on top, Aishwarya in the second place. Oh, the third position has been swapped. Neha is in third position. Come on, we are running out of time. Please attempt. Yes. We have completed our final question. And yeah, 55% of the attendees have been opted for the correct answer. That's nice. Yeah, let's end the quiz. And thank you so much for participating in the quiz.
That was amazing. An insightful session and an informative quiz. People, the most important thing to earn is respect, and the most important thing to spend is knowledge. Our next speakers possess both of these qualities. Let's dive into the next session. Please join me in welcoming Sarbani Maiti and Tanmay Roy. Sarbani is the Vice President of Data Science at Visa Technologies. She is also the leader of Digital Transformation Program with 20 plus years of experience in large investment banks. She has helped many businesses transform their data into measurable value and bring great change in the organization. I also welcome Tanmay Roy. Tanmay is a data science consultant at Visa Technologies. He was also an experienced researcher at the University of Johannesburg and has also worked in software industry on speech emotion recognition using machine learning and deep learning techniques. Our speakers will be talking on readmission prediction for heart failure patients using Sagemaker and AWS Comprehend Medical. I welcome you both. Over to you.
Thank you, everyone. Thank you for the nice introduction and welcome everyone to our session. I hope my slide deck is visible. Can someone please just give a notification if the slide is visible?
Yes, it's visible.
Okay, thank you, everyone. So my name is Sarbani Maiti. I'm working as a VP Data Science at Visa Technology. My co-speaker Tanmay Roy, he is a doctorate and data scientist consultant. I will start the session and he will conclude. Our session is about one of our project, readmission prediction for heart failure patients using Sagemaker and AWS Comprehend Medical. In the last session, Ilana has nicely described most of the AWS services, ML services, and LLP services, and he has also kind of touched upon this SageMaker and Comprehend. In this particular session, we are going to talk about a particular use case where we have implemented all the services along with some sample data set. The background of the project is here. The data set is taken from US healthcare industry, and that particular use case is applicable for US healthcare because readmission is a problem in US healthcare because there are a lot of penalties are applicable for this kind of cases. In US, around 6 million adults, it is a statistics, who are kind of admitted due to heart failure, and that is taken from 2015 to 2018 statistic. Readmission rates for heart failure patients, it remained 20%, which is quite high. Center for Medicare and Medicaid Services, CMS, is penalizing the hospitals for unplanned readmission, and it's kind of creating a loss of around $2.5 billion. So we can see we are talking about a problem which is $1 billion industry. And the problem is readmission, like when a patient is admitted, treated, and going home, and after that, within 30 days, patient is again readmitted due to any kind of complications. There, it is treated as readmission. But yes, the readmission is not all the cases. There are certain cases, there are a lot of logic and rules are applied at the hospital and the provider level and at the different institutions to detect whether a particular case is readmission or not. But in our use case, we have focused on all the heart failure patients, and we have put a simple logic that if the patient is readmitted within 30 days, then it will be treated as readmission. Now, why are you talking about NLP in this particular case? So in the readmission cases, we have extracted the data from one famous database, Mimic3. In Mimic3, we can see a lot of hospital patients' data, which are stored in the form of EHR and EMR record. Like we can extract a lot of discharge summary, clinical notes, and patient-related records, which are extracted from the lab reports, which there are a lot of blood samples and test sample reports. They are all stored there in Mimic3. It's a huge database. Now, in that particular database, we can see a lot of data are stored as structured data. It's a typical tabular format. Let's say the blood report, the creatinine level, the CVC. There are several numbers, and there are several reports are stored in the sample and structured format. But there are a lot of reports are captured in the unstructured format, which are called typically clinical text, discharge summary. We can see this, it's a whole lot of information which are tracked in a typical free text format. So to do this extraction, we had to apply NLP. Now, at a very high level, NLP is a machine learning technology that gives computer the ability to interpret, manipulate, and comprehend human language. Right now, it's not only healthcare industry. In each industry, whole lot of information is trapped under unstructured data. Now, that volume of the unstructured data is huge. It's in the terms of voice, text data, various communication channels like emails, text message, social media, news feeds, video, audio, and many more. If we start extracting the information for such kind of NLP or text or voice or images, then we can extract a lot of insight which will be helpful for building a model. In this project, we have merged the structured data and unstructured data, and then we build our model to gain some accuracy. This is a typical NLP pipeline, what we generally follow: sentence segmentation, tokenization, parts of speech tagging, lemmatization, stop word identification and removal, dependency parsing, noun phrases, named entity recognition, and co-reference resolution. And this kind of NLP pipeline is followed by a typical use case like text classification, document classification, question answering system, translation, text summarization, sentiment analysis, text generation, and many more. What are these different tasks? Word sense disambiguation. So let's, if you look at this previous slide, sentence segmentation is where we break down the entire paragraph or text into sentences, and then we break down the sentence into token, which is called tokenization, and then we try to identify the parts of speech, and each word or token is tagged as noun, a pronoun, adverb, preposition, and different parts of speech. Then we apply the lemmatization technique, where we try to find out the root verb or root word. Let's say running, the root word is run. Then stop words. There are several stop words we use in our English language, like is, are, the, and this kind of stop words apply. This kind of stop words, the number frequency of the stop words are quite high in any kind of text. So it is important to identify them and remove them, so that model is trained on the keywords which are really meaningful. Then there is dependency parsing, where we try to establish the relationship between various tokens, and words are used in a sentence in very various contexts. So this kind of contextual semantic relationship are established, and we try to identify them, and then the model is built. Noun phrases, named entity recognition, co-reference resolution are similar kind of techniques are applied. Now, let's look at clinical text, because in our use case, we are working with healthcare data. And healthcare data is quite different from the normal English language, because the complexity of the domain knowledge as well as the typical medical jargons. So like different disease, name of the disease, name of the drugs, there are a lot of treatment which are very difficult to follow in normal English language, because they are not part of our normal English dictionary. They might not be having carrying any meaning if we just follow the normal dictionary, but typically they are name of a drug or they are name of a procedure. So for this kind of clinical text analysis, we also need to build a Medicare or medical or healthcare specific model, which will be able to understand all such medical jargons. Now there are typical NLP tasks which are followed in the clinical text analysis are word sense disambiguation, where we look at the associating words in context with their most suitable entry in a predefined sense inventory. So I'll show you one example in the next slide. Name entity recognition, relationship extraction, and negation identification. Others like semantic role labeling, information extraction, co-reference resolution, and grammatical error correction. Now, what are they? Let's look at an example here. So if we look at the different kind of text in medical industry, we can see EHR and EMR. EHR is electronic health record, EMR electronic medical record. Then we can talk about clinical notes, history and physical notes, discharge summaries, radiology reports, lab reports, and all this kind of text will carry lot of medical jargons, like physician specific. A lot of doctors, physicians, they apply their own notations, own abbreviation when they are writing the discharge summary or clinical note. Domain specific shorthand conversations and different conventions, context specific terms and acronyms, sentences which are changed into different kind of phrases, because sometimes they generally do not follow any typical grammar, or they don't write that entire sentence because they are always in hurry, they have to treat the patient. So there are a lot of times we see the typical medical phrases are written on our discharge summary or prescription or clinical note. And because of this kind of complexity in this language or text, we need to apply a typical medical text analysis pipeline. So one is the relationship extraction. Let's say there is a sentence we can look at as an example. We used hemofiltration to treat a patient. So hemofiltration to treat a patient. So treat is just a word which is associated with two different words, hemofiltration and patient. Hemofiltration again is a technique or procedure and which is applied on a patient. Then word sense disambiguation. If we look at just two letter BK, the patient underwent a left BK amputation. And in the next paragraph, you can see here it is used as this is used, the same BK is used here as a virus. So just BK has no meaning in English language, but here it is used in two different meaning, amputation as well as virus. Another important is named entity recognition. Even in our previous session, we have seen the description. But how it is different in the medical world, the entities are different here. Like here, we are talking about disease. Here, we are talking about different kind of medical test, lab test, treatment, medications, anatomical sites, organ site, procedures, findings, and we'll see a lot of codes, which are called medical codes, billing codes. Then we'll see negation identification. Again, it is important. In negation identification, we try to identify this kind of sentence where we say like, patient has stopped taking medicine. Patient has stopped coming to hospital for follow-ups after discharge from the hospital. So these kind of negations are important to predict, let's say, readmission cases. If patient has stopped taking medicine, definitely there is a chances of readmitting because the risk will be high in those cases. So this kind of negation is different in the medical text. Now let's talk about our project and demo. Inspiration of our project, as we have already talked about it, readmission is a problem in the medical industry. In the CMS statistics and lot of research, we found that there are several diseases which are kind of listed in the readmission cases. Some of them are listed here: acute myocardial infarction, chronic obstructive pulmonary disease, heart failure, pneumonia, coronary artery bypass graft, elective primary total hip, and some sort of disease here. Here in our use case, we have picked up the heart failure because comparatively the heart failure cases are higher in this particular list. The objective of the model is to build a model which can predict 30-day readmission cases for heart failure ICU patients. And we are also trying to predict the top factors or predictors which are influencing or increasing the risk of heart failure patient readmission cases. The data strategy, in the next few slides, I will be talking about mostly AWS Comprehend Medical, how this particular service help us in our use case, and then Tanmay will take over and talk about the detailed use case. In the data strategy, we have extracted our data from Mimic 3 dataset, and as a high level, we have used the patient demographic and hospital mortality, laboratory test result, discharge summaries, billing related information, and current procedural terminology CPT codes. Now, how AWS Comprehend Medical is helping us? If we look at the use case or offering from the AWS Comprehend Medical, we can see Comprehend Medical can extract medical information from unstructured medical text, and it can identify the relationship between words. So here in medical text, we'll be looking at various kind of medical entities, as well as we'll look at various codes. So there are three different codes we'll look at here. One is that ICD-10 and RX norm and SNOMED city. Then another good thing about Comprehend Medical is that this is a AWS managed service, and once we can extract the information by using API. We can send the request and we'll get the JSON format response, and then we can use the JSON output in our own code, and we can parse and we can use it in our custom model. Then we can also use the typical AWS Comprehend console, and we can also use it for some real-time analysis, and we can check some of the text real-time on the screen, or we can use some batch analysis as well. And everything is secured because it is using AWS Managed Security Framework. Here are the offerings from the Comprehend Medical API. There are two different APIs are offered. One is the Text Analysis API, another is the Ontology and Linking API. Text Analysis API, we can see the detect entities like anatomy, organ site, drugs, procedure, different diagnosis name. This kind of medical entities can be identified by using this detect entity API. There is a function what we need to call when we call this function from our own code. Detect PHI, detect protected health information. Now health information is protected, so there are 18 different terms are listed as per the CMS guidelines, which are treated as protected information and cannot be transferred from one system to another system or cannot be exposed to the public world. So it's something like name, then it's kind of date of birth, address, zip code, and there are a lot of other patient demographics. So if we extract a discharge summary, let's say the discharge summary is talking about Mr. So and so is suffering from this disease, the name of the patient will be detected as PHI information, and it has to be de-identified before we use that discharge summary for our project. So this is important to detect PHI. If we want to do it with our own code, definitely we have to write our own module. It has to be tested with a large amount of data set. But in AWS Comprehend, we can get a ready-made API. Then the ontology linking. So Comprehend Medical extract the entities, and then it will link all the entities with different medical codes, because in medical industry the discharge summary, clinical notes are most of the cases converted to different codes. Diagnosis are mostly converted to ICD-10 codes, and then it is linked with the different procedures which are called typically CPT code, and these codes are used by the medical coders. They are validated, and then it is sent to the billing system for medical claim settlement. So these codes are very important to identify the relationship between diagnosis and procedures, whether a treatment is undergone correctly or not. All the verifications are done on the basis of the codes. This ICD code detect possible medical conditions or diagnosis, typical diagnosis of that particular entity. So it is important to extract entity and attach with the code. Then RX norm, again, it identifies the medications that are listed in a patient record as entities. SNOMED City detect medical entities and link them to concept, which is kind of 2022 version 3. And then the similar codes are used further in the downstream system. In the API selection, we can see the category types, trait, and attributes. And we can select whatever is required for our custom model. So in this project, we have used the types from the detect entity API. This is a quick look on the Amazon Comprehend screen. On the left hand side, we can see real-time analysis jobs, and in customization, we can also create our custom classification, entity recognition, and endpoint. Here is an example, like here we can put the input text. This is some real-time API is already given by the Comprehend on the console, so that we can quickly test or check how it works. So if we look at it, there are some name of the patient, and something is written here. This is Amazon Comprehend, and if we look at the typical medical Comprehend medical UI screen, so this is a Comprehend medical UI screen. You can see the text is now changed to a discharge summary. A woman is suffering from some disease, and there is some drug information is given, the medicine information, and when the medicine will be taken, and everything. If we look at the below, there are different entities are given. What we have just talked about, entities, RX norm, ICD-10. And if we just select one of them and press analyze here, it will show us this kind of nice interface. Here you can see all the entities are identified, they are highlighted, and they are also Comprehend has established a relationship between two entities. So status, post, cardiac, catheterizations, there is also a kind of date. So it is taking when that particular catheterization was happened, and then we can see what kind of sleeping trouble, so it is also kind of selected. So it is a dx name. Dx is diagnosis, so the diagnosis has been done, and these are the diagnostic entities which are identified and highlighted. Again, palpitation is a diagnosis, chest pressure is a diagnosis, and then it is also telling a organ site. You can see chest, this is also kind of, you can see there are doubly it is underlined, so that the chest has been identified as a diagnosis information, as well as it has been identified as an organ information. So the same way it continues, it's giving more detailed information here. Then if I go there, here we can see the application through which we can extract the information. On the left hand side, this is the API request. On the right hand side, we can see the API response, the JSON format. The ID and information is coming here in category. It is saying protected health information, PHI. And it is also kind of giving what is the protected information is coming here, type, profession. So this is protected. What kind of profession? Then it's written here, text, high school teacher. The similar way we'll get a big list of JSON element, and that can be parsed. How to parse a small function here, what we have used in our project. This function will show you. So here we are using Boto 3 to connect to the AWS services, and this is the detect entities version 2 function. All the functions are listed in the AWS tutorial, and you will get all the nice description, and we can select whatever is required. Here we are passing text equal to input text. Input text is nothing but our distress summary, what we have extracted from Mimic 3 database. And once we'll pass the text, the Comprehend will call the detect entity function, and it will identify all the entities, and it will return it back to the code, and then we have used it, what Tanmay will talk about. After that, I want to hand it over to Tanmay, and he will take you through the code and rest of the implementation. Thank you all. Tanmay, this is for you.
Hello, everyone. So thank you, Sharvani. I'm just starting presentation. So is my screen visible? My slides?
Yeah.
So as Sarvani has already mentioned that we work with both structured and unstructured data. So let's first look into how we formulated the structured data. So Mimic 3 is a database, freely available database, which contains like 40,000 ICU patients with de-identified data. So when we approached the problem, we saw that it is Mimic 3 is actually using a old ICD 9. Current standard is ICD 10, so it is using ICD 9 standard. But anyway, we can still relate. And so based on that, our understanding of the problem, we tried to find the list of ICD 9 codes which could be affecting the heart failure patients. So these are the list of ICD 9 codes which are important for heart failure patients. So we can map it with ICD 10 if required. So based on those ICD 9 codes, we have extracted the data from 4 tables from Mimic 3 database. One is admissions, which contains the details of admission type, discharge time, admit time, and other few demographic informations as well there in the admissions table. Apart from that, the patients tables also contains some demographic informations. There is another important table called lab events. Lab events is which contains the lab tests being done during the ICU stay or hospital stay. So it contains lab events, contains the results of the individual tests, and another table is called the lab items table, which is kind of a master table of the lab events. Means there is a definition of each of the lab items in that master table. So we have extracted the data from these 4 tables mainly. And one important thing is the lab events, which are when we actually saw the data, we saw that there are huge number of tests being done on particular patient. For let's say for if patient stays there for 10 days, there are a lot of tests being done on the patients, which may not be as important for the heart failure patients. So we have studied further, and we found that these are the 4 important items. These are the 4 important lab items which could be affecting the heart failure patients. So this is serum creatinine. Actually, these are very common terms in current days. People are suffering from different heart problems. So these are the tests being done regularly, like sodium, urea, nitrogen, ND-Pro, and BNP, like this. So we have selected those tests specifically, and when we saw that because these tests are done on a patient multiple times, so we cannot take it a single value of the data. So you have to somewhat average out the total number of from the total number of events taken place. So based on that, we prepared the data, and finally we got some. This is the snapshot of the actual data we extracted from the Mimic3 database based on the directions we have discussed so far, and we have calculated the target, which actually contains which comprises the 30-day calculations and all. So 1 means it is readmitted, and 0 means not readmitted. So we also calculate the duration. Duration is something from the discharge date, from admission to discharge date. It contains the days. So total of we have got like 13 columns and 6,219 rows. As you can see, the data here that we found since we are working on a specific problem, heart failure, so we don't have much data to extract. If we have taken the whole data set, then we might have get more information, more data. So now let's try to find how we process the unstructured data. Here the unstructured data means text, which is the distress summaries of each of the patients, which is taken from another table called note events from the Mimic3 database. We extracted the data from the note events, and then we put into, after some cleaning and all, we put the data in, send the data to Amazon Comprehend Medical, and we get some output, as Sharvani has also shown us that how it looks like. So based on those data, we actually extracted the DX name. Means that is the important part we thought may be important for our analysis. So we use DX name, which is a diagnosis name. So this diagnosis name it contains different words and different stop words and all. So we have to do some cleaning as well, because we have to prepare this DX names for topic modeling, because we have done a topic modeling on the DX names. So like we have done some cleaning, lemmatization, and unwanted character and word removal, all these things. So after that, we prepared the data for topic modeling, and during the topic modeling, we have used coherence score and NMF model to get the optimal number of topics. So what we found that 5 is the optimal number of topics we can get from this unstructured data, what we have extracted from Comprehend. And so based on those 5 topics, we label the unstructured data. Means each of the row will get some topic attached to it, and finally this topic will be combined with the structured data we had just discussed before. So this is the sum of the words we have found. Like 15 words we are showing for each of the topic. These are the 5 topics, and these are the 15 words we have received based on the topic modeling we have done so far. And this the word cloud we have tried to build, and you can see these are the disease names and all these things. And this is the similar code as Sharvani has already shown us. So this is the code we have used to extract the comprehend. We have called the comprehend service, medical service, and extract the data, and we have selected the DX name accordingly. So this is the snapshot of the implementation of in Sagemaker. We have implemented the whole thing in a Sagemaker. And this is the result we have received from the classification. We have tried different models, but random forest and MLP given us the best results. Random forest has given us a recall rate of 85%, but MLP is also given us a recall rate of 82%, but MLP has a bit higher accuracy of a bit higher. So overall accuracy is low, as you can see. But since the recall rate is high, which is our main target, means we have to identify the heart failure cases, means readmission cases for heart failure. So it is actually, this model is actually predicting quite good. Means for initial result, this is encouraging for us to get a 85% recall rate for the target class. So this is the current solution, and we are still working on it to make it more robust and get more better accuracy. So now this is the feature importance we have received from tree-based structures, means random forest and decision tree. These are the list of features which we found important. As you can see, age and the 4 tests we have selected are the top features, but interestingly, the topic which you have extracted from Comprehend, Amazon AWS Comprehend, which is the most important, other than the medical tests and all, is the most important feature. So it is definitely this AWS Comprehend is giving us some good input, and we are also trying to extract more features from AWS Extract. So and other features that you can see in the listed here. So what are the next steps? As we've already told, that we try to include some more features from Comprehend, like RX norm. Sharvani has also told us regarding this. So we would like to analyze more, and so that we can maybe include more medical tests, and so it will be more robust. Maybe we'll try more advanced NLP technologies to do a better topic modeling, and also obviously the classification model. There is scope of improvement. So that's it. Thank you for this wonderful event. We are glad to present our work. Thank you.
Thank you so much, Sarvani and Tanmay. That was a very insightful session, and the demo was also very insightful. Thank you so much for sharing your amazing knowledge with us.
Thank you.
So let's see if there are any questions. I don't see any questions in the chat right now, but if
Yeah,
there are any
definitely.
questions, we will pass on to you. So please
Definitely.
join in the YouTube chat, and you can answer those. Thank you so
Sure.
much for joining.
Thank you.
Thank you. Thank you
Thank
so
you
much.
all. Thank you both.
Thank you. Bye.
All right, everybody. I hope you really enjoyed this session. Now would be a great time to provide your feedback in the comment section below. So the session is over, but the session quiz remains. It's time to test your knowledge. So please scan the QR code that is being shown on the screen. You will have 2 minutes of time for joining. And for the people who hasn't signed up on Quiz Hub, please scan the QR code. And for any technical problem, if the QR code doesn't work, there is a link given in the chat. Please feel free to register on the Quiz Hub and play the quiz. Let's meet up in a bit. All right, everybody, I am now going to present the quiz. All right, so I hope the quiz is visible on the screen. And yeah, let's get started with the first question and let's see who leads the leaderboard. So 3, 2, and 1. Which of this is not a machine learning type? Supervised learning, creative learning, reinforcement learning, and unsupervised learning. I see there are a lot of people answered the correct question. There are 206 participants. All right. So let's see the stats. Okay, so 75% of the participants have given the correct answer, and Aditya is now topping the leaderboard. So let's go to the next question. And it's now on the screen. Which of this is not AWS AI service? Recognition, Poly, Fargate, Lex. Which of this is not AWS AI service? I see a lot of people has given the correct answer. And we are running out of time. All right. So yes, the Fargate. So Fargate is a compute service. It's not an AI service. It's basically a development environment where you can create the AWS AI services. AWS AI solutions. So let's jump on to the next question. And we see Ashish Kumar on the leaderboard now. So here's the next question. Amazon SageMaker is a part of AI services, ML services, ML framework, and infrastructure, none of the above. Okay, so we have Aditya Avati on the top, Aishwarya Sood on the second position, and Dhaval on the third. All right, people. There are amazing goodies for the winners, for the top 20 winners of this quiz. All right. So 25 participants has answered the answer correctly. It's ML services, and Aditya is leading the leaderboard. So let's move on to the next question. All right, here comes. Is Lex a part of computer vision? True or false? Okay, we see a change in the leaderboard. Dhaval Chorwatkar has got all the four correct, and then we have Aishwarya Sood. People, there are amazing AWS, amazing goodies for this quiz for the top 20 winners. All right, so yes, let's see the stats. Yes, is Lex a part of computer vision? False, because it's a part of it runs on the principles of natural language processing. All right, that was all. I'm ending the quiz now. Let's move on to the next session. Thank you so much for joining the quiz.
Yeah, thanks, Tahir. It was a wonderful session, wonderful quiz after this session. And congratulate Dhaval for topping the leaderboard. Now, let us invite Shafali, our next speaker. Shafali is founder and director of Rashiv Cloud Solutions. She is cloud enthusiast, an AWS instructor, and a mentor. She has 12 years of experience in IT, academics, and corporate trainings. She is currently working as AWS lead instructor in Tech Talent Academy. Shafali will be sharing her incredible success story with us today. I welcome Shafali. Over to you.
Yeah, thanks for the opportunity. Hi, everyone. Welcome to AWS Community Day India. So, I'm Shifali Arora, Director at Rashiv Cloud Solutions. I'm a core tech woman in computer science with around 13 years of experience. Today, I have planned to deliver a few insights of my 20 years journey in the next 20 minutes. I will share three topics during this session. In the first, I will narrate my story. Okay, that would be my career journey starting from 2001 till today. In the second part of the story, I will give you few examples about my learners who have succeeded in the cloud journey. And in the third and the final step, I will inform you about why it's necessary to be part of the cloud and how can you initiate your cloud journey in this platform of opportunities. So, with the context, coming to my first part of the journey, flashback in year 2001, I took admission to my engineering college in computer science stream. If you recall, 2001 was the year of 9/11, and IT industry went into a deep slump, right? So as a young student, many of my known people, like aunts and uncles, they started giving me opinion that computer science is not the right field. It's going through slump and there would be less jobs in the future. Anyway, I decided to continue with my computer science stream. 2005, fresh out of the college, I did a 6-month programming course and had a wonderful start in my career by joining Satyam Computers, my dream organization. I was on top of the world since I was earning for self and was independent. During the early years of my career, everything went smooth and I was enjoying being an employee of a big corporate. Year 2008, the first turn in my career. My husband got on-site opportunity and in interest of family, we shifted to USA and decided to give up my first job of Satyam Computers. During this time, I planned my first baby as well, and life felt so amazing with addition of the new member in the family, and I forgot thinking about the job. 2010, we were back to India with a 2-year career gap and with my 2-year-old baby. In the urge of reviving my fancy corporate life, I started preparing for job interviews. So I did a couple of quick certifications and started my second job in IT. With this new job, beyond my imagination, I started struggling to create a balance between the high demanding IT jobs and my family. And leaving a 2-year-old kid in daycare for long hours became unacceptable to me. So one fine day, I decided, I discussed at home and took a hard call to give up my second job as well. Believe me, it was a difficult choice. At that point of life, I realized it's time to switch to a domain where I can grow professionally and give time to my baby, and so decided to shift to a college job, which is usually 9 to 4. After doing a bit of research, I found that doing a college job requires a master's degree as a minimum eligibility. So now the time is to start with my studies again. So 2012, moving forward, I started preparing for the entrance exam for my MTech and enrolled for masters from Mumbai University. Thinking of going to a college as a full-time student after 7 years of my graduation was creating turmoil inside me. I was in dilemma whether I would be able to make it into my ME until I cleared my first semester of ME. And then 2013, while pursuing my ME, I joined a professorship in an engineering college in Mumbai. My third job seeking the work-life balance. Completing my ME successfully was not easy as it could be. The reason is before I could get the date of my final Viva from Mumbai University, we shifted to Bangalore for my husband's new job. 2015, there was a third break in my career due to shifting to a new city and another addition to my family. Yes, my second baby. And I think it's normal in females' career, right? Many of you would able to resonate this. So give me a thumbs up on the chat if you have a similar story. I traveled all the way from Bangalore to Mumbai with my infant for my final vive of ME and completed my ME successfully and now without a job in Bangalore. 2017, still new to the city with a newborn baby, I started preparing for the job interviews and after having couple of them, I started with my fourth job. It's an assistant professor in engineering college. 2019, a turning phase in my career. So here I started attending different technical workshops from my college. Few of them were Infosys workshop and also from the AWS Academy to become AWS educator. These workshops were quite far from my place, and I still remember on the last day of my workshop, it was my daughter's birthday. When I reached home, my husband and all my guests were waiting to have, to cut the cake alongside with my daughter ready in the pretty dress. These all efforts paid off eventually, and I finally got an opportunity to become an AWS educator in college and got my first certification of AWS Cloud Practitioner. I celebrated this achievement by taking my kids to a movie theater, which was just nearby my house, and they still cherish these moments. It's always good to celebrate the small winnings. That is what I believe in. After getting certified, I started delivering cloud essential trainings to my college students, and I was enjoying learning AWS technology parallelly. 2020, with a full time job, being a mother of two kids, taking additional time for learning was not easy. But my eagerness and curiosity to learn new technology led me to achieve my AWS Solutions Architect Associate certification, and I became the first faculty to achieve this in my college. Through my LinkedIn network, I started taking guidance from the experts working in similar domain on how to proceed further in my cloud journey. LinkedIn family is so amazing. I got a lot of guidance from the experts, and then the life-changing moment happened. 2020, I got an opportunity to appear for ICA workshop, that is Instructor Candidate Authorization. It's conducted by Amazon training partners to become an AWS authorized instructor, AAI. So if you are wondering what is AAI, it's a global program that gathers all instructors authorized to deliver official AWS curriculum via AWS or ATPs. Believe me, that time I had no clue what this workshop was all about. but I started preparing for it parallel to my full time college job. And I failed miserably in my first attempt to clear AI. But on a positive note, I realized how much deep dive knowledge is needed to earn the AI badge, and I set my goal to achieve it. Putting 8 to 10 hours per day of efforts learning AWS was the need for AI preparation, and it was very challenging with a full time job. I was standing at the junction where I need to take a decision to continue my college job or to continue AWS. I took a hard call, left my existing job without having another job in my hand in August 2020, and started preparing for AWS and was hoping to have a bright future there. During these tough times, my family stood with me and supported me through ups and downs. I started delivering freelance trainings for AWS to polish my skills and also invest some money to take additional trainings from experts personally. After 3 months of continuous efforts, it was time to reappear for the ICA workshop in November 2020. And you guessed right this time, I cleared it. It was a golden moment, an honor for me to achieve the AI badge. In couple of months, my LinkedIn started flooding with requests for delivering the trainings. I became AWS Restart Accredited Instructor and delivered around 10 batches of AWS Restart training as of now, and also delivering the Train the Trainer sessions globally. Once I started delivering trainings, it came with good financial rewards and gave me exponential growth that I could never achieve working in the college. 2021, I officially registered my own company, Rashif Cloud Solutions, and today I am running my own startup for corporate trainings and collaborating with different clients in and outside the India. The whole purpose behind starting with IT trainings is to produce the skilled workforce in emerging technologies like cloud platform, data science, full stack developer, and many more, making the people ready for the IT industry and to give back to society by reducing the gap of IT skilled resources in the market. Success is not easy to get. We need to overcome several hurdles on the way. I'm grateful to God for setting up this incredible success story for me. Coming to the second part of this session, I would now share a couple of examples how my students and learners have progressed in the last 2 years. To list a few, many of my students gained IT jobs after completing the AWS Restart course and getting certified with AWS Cloud Practitioner, who were from completely different domains. I have trained the people from sales, hospitality, delivery boys, and so many diverse non tech backgrounds and helped them to gain better paid IT jobs in big corporates. Hearing such success stories brings immense pleasure to me. Another example I'm observing is a woman in her late 40s. She's from a commerce background. She has so far only taught kindergarten students in the school. And recently, being passionate, she has taken the AWS Restart course and got certified with the AWS Cloud Practitioner. And now she has started writing the technical blogs on AWS. She is already getting the calls from the freelancers as a freelance content writer. This is the advantage of learning technology. So, the message I would like to pass on today, looking back into these years, for me, it may have taken close to 15 years to reach to this level, but for you, it may be 1 year or 3 years ahead since we are in digital era today. So take control of your own journey, decide fast and start today. Looking back, I can surely say if I could do it, you all can do it as well. Coming back to the final part of my story, let me tell you why you should start learning cloud, and also I'm going to cover what and how needs to be done to start with your cloud journey. So let's have a look, but before that, I would like to share my screen. Okay. Yes. So let me please confirm once. Are you able to see the links here? Right?
Yes, yes, Shubha.
So, okay, thank you so much. So let's start with the growing demand and job prospects in cloud computing. These are the predictions from the experts for 2025. And if you see here, the job market and the market for cloud computing, it is expected to reach $482 billion in 2022. So, especially after the pandemic, exponentially it's growing and creating a lot of opportunities around the world. And if we talk about the popular cloud computing job roles and salaries, let's have a look on it. So, cloud administrator, once you are into the cloud, there are huge domain of roles: cloud administrator, cloud application developer, cloud network engineer, cloud automation engineer, security manager, cloud engineer. Then we have site reliability engineer, cloud architect, DevOps, never ending domains we can see here, right? And here is also the prediction about the salaries in the market. So for different countries, we have the salary range for the cloud engineer and the cloud administrator and many more roles. And the companies who are looking for such people, you can imagine the growth that is coming and it's emerging, right? So the all the big corporates, Wipro, Accenture, Infosys, IBM, Bosch, McAfee, SAP, AWS, and so many. So this is the future. The cloud is the future, as you can see. Also, I would like to show you how the market is growing. If you see this graph, cloud computing industry market size, it is showing starting from 2018 and then till 2024. It's going to be $663 billion. That's so huge, right? And the reason is, now in this era, the small organizations, big startups, everyone, they are planning to migrate to the cloud. They are just shifting to the cloud. And zettabytes, I think in just upcoming years, zettabytes of data, that much huge data is going to be stored on the cloud. Some more insights, if we check, if it there are multiple cloud platforms in the market. If you see here, AWS, Azure, Google Cloud, Alibaba, IBM, and so many. So all these stats I'm showing you directly from the internet. AWS is one of the leading as of now, as we can see, and it leads up to $200 billion cloud market. This is the update of Q2 2022. So these are the reasons, I think, and the growth which we can see. I would recommend to start with your cloud journey. The other thing now I want to show is the footsteps that you should follow, right? So how you can start the cloud journey. If we talk about AWS, there are a lot of learning portals offered by AWS itself. One of it, as you can see on my screen, is the AWS Skill Builder. Now, this is a learning portal offered by AWS. It has huge number of courses in whatever domain you want to have, maybe the security, data specialty, machine learning, AI, cloud architect, any kind of domain that you are interested in. You just have to write your words here, and then you will able to see the list. Now in this skillbuilder.com, there are free courses as well, as you can see. Some are free and some are subscribed. In that case, you have to take a subscription. So it's a huge list. Please take advantage. Start with the small, start with the free trainings first, and then later, based on your interest and your domain, you can do a deep dive. So this is the first portal that I want to show you. You can learn it at your own pace. Next, we have AWS Educate. AWS Educate, this is just to build your skills at your own pace and then at your own time as well. It's completely free. Okay, this is completely free. You can explore so many education programs are there under this AWS Educate as well. There would be real-time labs, okay, starting from the foundation level to the deep level. Another portal which I want to show you is AWS Restart. Now, AWS Restart, this is a full-time 12 weeks course. So whoever enrolled for this course, it's going to be complete 12 weeks, Monday to Friday, 8 hours in a day. This course is running in more than 30 countries as of now across the world. And millions of people have been trained already from this course, right? Even as I told you, more than 10 batches I have instructed already. And the people are getting into the IT after doing this course. Now, some of the key points which I want to highlight for this course is that it is not only about the technical learning, but it consists of full package. So here you will get the guidance like interview guidance, resume writing, creating your LinkedIn profile, presentation skills, communication skills. It's a complete package in those 12 weeks. Another two main advantages of it. First thing, it is free of cost. It's amazing, right? So you are getting the instructor-led full-time course, but free of cost. And once you finish this course, you will also get an exam voucher that is for the AWS Cloud Practitioner, and it's also free for you. So many great benefits once you enroll to this course. Right. So I would like to spread this message to youth of India that it's never too late to learn any new skills. Start small, keep building over it to make your own success story. I would recommend start your cloud journey by today, starting from the fundamentals, taking the small courses, right? And then proceed to the intermediate level courses based on your interest. Also, you can take some hands-on tutorials, always available on these portals to gain the deeper knowledge for different use cases. So just the last few statements from my talk here. Keep upskilling and reinvent your future. We are in a digital revolution decade. So the faster you participate, the sooner you start your career path. Build your network on LinkedIn. Be more active. Start taking guidance from the experts. People are ready to help you. Are you ready to seek the help? Take up new courses, certifications. Spending on upskilling is not an expense. It's investment for your better future. Trust me. At last, if I can do, I promise each one of you can do. With this, I would like to thank Dipali Kulshresht and Rohini Gonkar from Amazon for giving me this opportunity. I would keep contributing and giving back to society. Thanks and have a wonderful day, everyone.
Thank you so much, Shafali, for the very enlightenment session. I'm personally so inspired from you and hope all the attendees have also inspired from this speech. So
Thank you so much. Thanks.
Yeah. So, all right, everyone. So, before moving to the next session, let us know more about our platinum sponsor, Corologics.
Of the many challenges facing businesses today, translating ever-growing data volumes into useful information and meaningful insights tops the list. For years, companies had a choice. Either spend huge sums to index their data and suffer poor performance and low scalability, or limit data coverage to improve costs and performance and risk losing critical visibility in the process. Today, with data quickly outpacing revenue growth, leaders need a better alternative. It's why businesses of every shape and size partner with Corologics, the next generation full-stack observability platform that provides infinite insights for logs, metrics, tracing, and security data when and where you need them. Data. Our next-level customer success group, made up of world-class SRE and DevOps talent, serves as an extension of your team, ready to respond in under a minute, 24/7 to keep your systems and business on track. Coralogic's platform is there as a partner to unlock more value and endless possibilities from your ever-growing data.
All right, people, that was a very inspiring session from Shefali. For the next session, we have the superhero of serverless, Yan Choi. He has been building on AWS since 2010, and he became one of the first AWS serverless heroes in 2018. And he has also co-authored serverless architectures on AWS second edition. He has written over 150 articles on AWS and serverless, helping thousands of developers in their journey towards serverless. He is currently working as a principal consultant in the Burning Monk as a freelancer. Yan will be speaking about how to choose the right messaging service for your workload. A very warm welcome to you, Yan. It's an honor to have you today. Over to you.
Hey guys, good morning. Nice to see you all. Let me just quickly share my screen so you can we can get the slides up. Let's see. Okay, all right, there goes my screen, and then let me start my slides. Yeah, so I guess welcome to this talk where I'm going to be talking about how to choose the right messaging service for your application. So I guess going back to the start of my, the professional journey, I finished my computer science degree at the UCL, which is the University College London. And one of the sort of lectures that I most enjoyed were computational complexity, where you learn about things like the big O notation and what is the NP problem versus NP hard or NP complete. Unfortunately, those things are skills that I don't really get to use in my professional career. But what it did give me was this like a framework to think about software complexity. So if you fast forward to today, I've been using AWS since 2010, and so it's been over a decade since I've been running stuff on AWS. And nowadays I work both as a developer advocate for Lumigo, but also I do a lot of independent consultancy work to help other companies go faster by adopting serverless successfully. So in my day-to-day work, I work with a lot of different AWS services, and I strongly believe that understanding how these services work is just as important as understanding different data structures and knowing when to use, say, an array versus a linked list. And, event-driven architectures is also a really big topic these days. And the key word here being driven, because our applications are built in such a way that it's going to do something useful when it receives an event. And the event is the thing that really drives our application to do what we designed it to do. But where do we send these events? And I think as far as AWS goes, EventBridge is kind of the king here, is the de facto choice that you use to build event-driven solutions and architectures on AWS. So as the event bus in your event-driven architecture, it lets you keep your publishers and your consumers of these events loosely coupled, thanks to the fact that you can do this content-based filtering so that consumers can decide what events they care about and listen for those events without having to constantly talk to the team that publishes the events to please add this other field to your message attributes in the case of SNS. So EventBridge makes all of this a lot simpler. But if you actually zoom out of your architecture for a sec, your application is maybe made out of different services. Each one of them will have their own domain, and they are sharing information about what's happening in the application with each other by publishing events to EventBridge, and then consumers will react to those events that are being raised elsewhere in the system. And if we were to look into any one of these services that you have in your architecture, you probably see some kind of event-driven business logic inside there as well. And for different workloads, you may have different requirements for the thing that's capturing and then capturing the events and then triggering your business logic. You often have things like functional requirements, things like there are things that are not that are non-negotiable. For example, you probably need FIFO so that you can make sure events are processed in the same order as they are received. So that could be very important for, say, e-commerce applications, or maybe you need to have the ability to replay events that's been captured so far, and it might be the case for an event source system that where you're building, where you need to make a bug fix and you need to the system, so you need to replay previous events in order to generate the new current state for your system. And you also have to think about some of the sort of non-functional requirements, things like how to things like how you handle errors, costs, and the scalability of the solution, so that your choice of the sort of messaging service that you use is going to affect all of these different things about your application. So they can be quite important to think about if you need to build a system to have the scale. And so you need to think about how the scalability of this messaging service is going to affect that, and also how your cost is going to scale with more and more messagings that you have to process. And because AWS offers quite a few different messaging services that can do similar jobs here, there are, these are just a few that comes to mind here: SNS, SQS, EventBridge, Kinesis, DynamoDB Streams, and IoT Core. But then there's also other things like MSK, the Amazon Managed Kafka service, as well as the ActiveMQ, and maybe half a dozen other services out there. So in general, knowing how to pick the right AWS services for your workload is a very, very valuable skill to have. And it all goes back to the point I made earlier that AWS services are the new data structures. You need to know how they work and when to use them in order to get the most value out of AWS. So for the next maybe 20, 30 minutes, we're going to do some mental exercise and think about how our choice is going to affect our application. And for the sake of simplicity, I'm going to focus on SNS, SQS, EventBridge, and Kinesis, because these are the most popular messaging services that people use in the wild. So let's start by thinking about how our choice of messaging service here is going to affect the scalability of our application. So when it comes to scalability, we have to really think about the scaling constraints on the service itself. And I think the best way to kind of master that is to learn to Google. When you want to find out the scaling constraints around EventBridge, you can always just Google EventBridge quotas or SNS quotas or whatever service quotas. The reason being that AWS has done a pretty good job, and they publish a quotas page for every service with some explanation for what each of these quotas actually mean for you, as well as the default values by region and whether or not these quotas can be raised. And for EventBridge, for instance, the most relevant quota for scalability is the number of put events requests you can make per second per region. And this page tells you what the default limits are for each region. And once you've got a decent understanding of the relevant quotas for the service that you want to use, you should also go to the service quotas page in the AWS console as well. So this is where you're going to find out the current quota value for your account and region. And you can also use this console to make a request to raise that quota for your account, and sometimes you have to fill in some additional information to justify your reason for asking for a raise. That's the case with say Lambda concurrent executions in the region, for instance. And besides understanding the scaling constraints on the messaging service itself, we also need to understand how it interplays with Lambda's concurrency and how it's going to scale with throughput. Of course, the assumption I'm making here is that you're building a serverless application using Lambda functions to process events as they occur. Of course, you can use Fargate or containers or even with EC2 instances as well. But my specialty and my focus is on serverless. So I'm going to focus on the serverless aspect of that. So if you put your Lambda concurrency and message per second that you receive on the X and Y axis, then for things like SNS and the Event Bridge, where these services would invoke your Lambda functions asynchronously, and if we were to publish, say, 100 messages to SNS topic, it's going to try to invoke concurrently 100 Lambda executions. So there's no batching. So every concurrency would, because there's no batching, so your concurrency would grow linearly with the number of concurrent messages that you are receiving from these services, which can be great if we are after having maximum throughput in our business logic layer to process these events as quickly as possible. Whereas with something like SQS, on the other hand, concurrency is controlled by the number of pollers that the number of the Lambda service runs on your behalf, so that these pollers would poll messages from SQS, and when it receives them, it's going to then invoke your Lambda function. So out of the box, the Lambda service is going to start with 5 pollers for every SQS subscriber function you have. And this can go up by up to 60 pollers per minute when you need to scale based on how many messages are coming in and going into the backlog. And you can scale up to 1,000 pollers concurrently. And each poller, when it receives a batch of messages, is going to invoke your Lambda function. So with SQS, the concurrency of your Lambda function is going to go up more gradually compared to SNS and the Event Bridge, partly because you get message batching, but also because the concurrency is limited by the number of pollers, which is growing at a rate of up to 60 per minute. So it's much less aggressive in terms of scaling compared to SNS or Event Bridge, where it's just going to try to fan out as much and as quickly as possible. And then you've got something that's a bit different in terms of scaling behavior. You've got Kinesis, where by default you have one concurrency, line of concurrency for every shard that's in the stream. So the concurrency is going to go up in pretty discrete steps, basically every time that a new shard is added to the stream in order to add more read throughput or write throughput. And for those of you who are not familiar with Kinesis, with every shard you can ingest up to 1 megabyte of data per second, or receive up to 1,000 messages or records per second. So you can actually get a lot of messages with a relative small number of shards. But then you can actually configure the event source mapping for your Lambda function to allow up to 10 concurrent Lambda executions for each shard. So you can process these messages quicker. The nice thing about this is that it still guarantees the ordering of the messages, so that each Lambda invocation will still process events in the same order at the partition key level, which makes this a really nice feature, so that you can, based on your setting, you can increase how much the Lambda concurrency grows as you add more shards, and therefore improve your processing throughput. And usually being able to use more Lambda concurrency to process more messages, process messages faster, is a good thing, except when it's not, because sometimes we do need to control the amount of concurrency that we're using, because maybe we are working with a downstream system that is not able to scale as much and as quickly as we can with our Lambda functions. Maybe you're talking about legacy database that just can't keep up with how you can go from 0 to 3,000 Lambda concurrent executions, or maybe it's a third-party service that has a rate limit that's baked into the service. So imagine if we were using SNS here, and we received a flood of messages, and suddenly SNS created a whole bunch of Lambda concurrent executions, invocations, and the Lambda functions is, it's fine. I will just scale from 0 to whatever you need or straight away. So that's great. You're processing messages very, very quickly. But then our functions need to talk to some downstream system, which can't handle the load that we're throwing at this system. And so at some point, once you go over the maximum throughput this downstream system is going to handle, we're going to get some errors. The nice thing that we get with async invocations like SNS and EventBridge is that you get built-in retries and then delta queue. So with any luck, even when we have this sudden spike in traffic and we're getting a bunch of errors for our invocations, a lot of those failures, we're just going to get retried a bit later. So the automatic retry makes sure that once the spike is over and it gets retried, we will hopefully be successful. So we don't have to worry about messages going into the delta queue that we will need to have to deal with later. But what happens if the spike was sustained over a period of time? And so even though you've got these retries, those retries is also going to fail because they're still way over the maximum throughput the downstream can handle. So eventually, we're going to exhaust the maximum number of retries we get, which is 2 retries, by the way. And now we're going to have to rely on our delta queues to capture those failed messages so that we don't lose them forever. But then we also need to have some other mechanism afterwards to reprocess those events that is now in the delta queue to make sure that they actually don't get forgotten, and then that we're able to process them once the spike has finished. In the case of Kinesis, this is where it gets interesting because any spikes in traffic that we experience is essentially amortized and would be just processed later, because we can control how much throughput our application is going to handle based on the number of shards we have in the stream, and also how many concurrent Lambda executions we configure for each shard. So based on those 2 configurations, we can essentially and plus batch size and things like that. So we can control how much throughput that we're processing from the stream, and therefore control how much throughput we're throwing at the downstream system, so that we never get to the point where we will overwhelm the system, and instead any sort of spikes that we experience would just be smoothed out, and some messages would be processed a bit later, a bit slower, but we're not going to overwhelm the downstream system. So in general, if you're looking for maximum throughput, then you should be looking at things like SNS or EventBridge. And on the other extreme, if you need to have really precise control on concurrency, then you should consider using Kinesis instead, where you can control the Lambda concurrency with the number of shards you allocate. And in between, you have this spectrum of other services that scales up the Lambda concurrency at different speeds as the throughput goes up. But you actually have another mechanism in place that you can use to manage the amount of concurrency that you use for a particular Lambda function that subscribes to SNS or EventBridge. And because you can use the reserve concurrency on Lambda function to limit how many, you also access like the maximum concurrency you can have for that particular function. So it's a really useful option to use when you have maybe 1 or 2 functions where you need to do this to control and prevent this one function from going crazy and end up using up all of your available concurrency in your region, or overwhelming the downstream system that is using. However, the problem with reserve concurrency is that they are taken out of the available the pool of available concurrencies you have in the region for all of your functions, which means if you allocate say 100 concurrency to one function as reserve concurrency, then that 100 units will be taken out of the regional pool of, say, you start with 1,000. So now you only have 900 concurrency that can be used by all the other functions in your region. So it's really easy to make mistakes and then overuse your reserve concurrency on lots of different functions. You end up leaving not enough concurrency for other functions that need to tap into your concurrency to scale dynamically. And you can also get yourself into a position where you are you don't have enough available pool of concurrency for dynamic scaling, so that other functions like API functions behind API gateway that is handling user requests from your mobile app, then they're going to get throttled, and then you're going to create even more problems than you're trying to solve with reserve concurrency. So reserve concurrency is useful for, it's more like a surgical tool for when you have one or two functions that need to do this, but it's not a good strategy for that can be applied broadly to lots of functions, because you're micromanaging scaling again, and also creating problems in terms of over allocation or under allocation and causing throttling elsewhere. And that kind of brings me to the next topic about cost, which often goes hand in hand with scaling. Because when you try to project the cost of your application, you always have to factor in the expected scale or throughput that you have to deal with into the equation. Take, for example, assuming you're sending one message a second for a whole month, this is kind of roughly how much you're going to spend with each of these services. So in a really low throughput scenario like this, Kinesis can seem much more expensive than other services, because it's got this baseline cost, because you have to pay for the shard hours. Although in terms of the absolute cost, absolute terms, is $10 is still not a huge amount in the grand scheme of things. And it's also worth mentioning that Kinesis nowadays offers both on-demand pricing as well as a provision-based pricing. And with the on-demand pricing, you're not paying for uptime for individual shards, but for the whole stream instead. And also it means that you don't have to manage the number of shards yourself and have to deal with auto scaling and all that. Instead, you just pay for the amount of data that's being ingested and received. And so if we add the Kinesis on-demand to our list as well, you can see that it's even more expensive than the Kinesis provisioned. And still not a huge amount by absolute terms, but in terms of relative terms, it's a lot more expensive than the other options. But then if we scale our throughput to, say, 1,000 messages per second for a whole month, now services like SNS and SQS and EventBridge has now become a lot more expensive pretty quickly. And the Kinesis becomes significantly cheaper, even with the provision mode. Even with the on-demand mode. The reason for that is because the cost for Kinesis grows much slower, because its cost per million API calls is much lower than the other services. So as the scale goes up, its cost is going to grow much more gradually. And that's a good rule of thumb when it comes to AWS services, that the services that charge by uptime tend to be orders of magnitude cheaper when you're running at scale. So that's something you want to keep in mind, and this is something that's very much something that's on the minds of the engineers at the Wiley, which I spoke to, and they are the national broadcaster in Finland, and they got this system for ingesting and analyzing over 500 million user interactions a day, and at a peak of about 600,000 messages per minute. And I was able to speak with Anahit Pogosova about this on my podcast a while back. And she worked on this particular system. And like the rest of her team, she's a big fan of serverless. But because of the throughput and scale that we are dealing with here, they decided to use Fargate and Kinesis for this particular workload. Both decisions were driven by the throughput of the system and the fact that they need to be cost efficient. And when it comes to implementing this system. You also maybe notice that the SQS is somehow in the mix here. And the reason for that is because it's there as a fallback in case the Kinesis service is down for whatever reason, so that they don't lose any events. They can then just ship those events to SQS as a manual data queue instead until Kinesis comes back online later. I think this was implemented before Kinesis. Actually, no, sorry, that's a different thing. But yeah, this is in case Kinesis goes down. So that brings us to error handling. How we need to understand the failure behavior between Lambda and the messaging service that we want to use. Like I mentioned before, one of the great things about using Lambda to process events from, say, EventBridge is that as a async invocation for Lambda, you get up to 2 retries out of the box. And it also has support for data queues as well. But the thing about the data queue here is that it only captures the event that your Lambda function was not able to process, not the context around why they failed. So it's now up to you to figure out that it failed and whether or not it's why it failed and whether or not it's safe for you to reprocess a message. And oftentimes that means going back to your logs and see if you can find the relevant log message for this particular event, and which requires you to have good correlation IDs and good message errors logging, all the other stuff. So you have to spend quite a bit of time to figure out on a case-by-case basis whether or not why a certain event failed, which of course can be time-consuming and tedious, especially when you've got lots of failures because of sudden spike in traffic and lots of things get retried but still fail because the spike was sustained over some period of time, like we talked about earlier. So the Lambda team decided to do something better. And so now you have Lambda destinations as well. And compared to data queues, it's got some significant advantages. For starters, it's not limited to async invocations and supports stream-based invocations as well. So it also works for functions that process events from Kinesis and DynamoDB streams, but it doesn't work for SQS, which has got its own mechanism for DLQs. And it also supports more targets besides SNS and SQS. And you can use EventBridge and the Lambda as destinations as well, which is very useful if you want to run some kind of automated logic in the event that you captured a failure. And with the on-failure destination, it also captures a lot more information compared to the vanilla data queue as well. It still have the same event payload that your function couldn't process. But importantly, it also captures information about the invocation, the number of attempts, but most importantly, the error and stack trace from the last attempt you made at processing this event, which saves you from having to go through the logs and try to figure out yourself. And this is why you should prefer Lambda destinations over data queues nowadays. Although it's possible for you to use both of these things together, but I've never seen any use case where it would make sense to use both. And I think Lambda destinations are great, but Lambda destinations also has some problems as well. Specifically when it comes to dealing with stream-based invocations, where this is what the information the on-failure destination is going to capture. So you have the request and response context, which is great. You've got the timestamp, the shard ID, the start and end, the sequence number, the stream AIN, and so on. But notice what's not on here: the actual payload that you got from Kinesis. So instead, you have to use the shard ID and the sequence number to then get the payload from the stream yourself. But you have to do this before the data is expired. So if this is the first time you see one of these messages in the destination, and then the failure happened over the weekend when everybody is away, then there's actually a very good chance that you can lose data because no one noticed this before the data is expired. unless you are lucky or unless you have enabled extended retention for Kinesis to cover the few days at least. And of course, that comes with extra cost. And as I mentioned earlier as well, this mechanism, Lambda destinations, doesn't even work for SQS functions at all. So for SQS functions, you're back to having to rely on delta queues from the SQS, its own sort of redrive policy feature, which means you're going back to not having those error stack trays and having to look in your logs to figure out why messages failed in the first place. So again, that requires having good discipline in terms of logging the relevant information that's going to help you later to figure out, okay, given this message that we have received, we are logging something about message IDs that we are processing it, and then when there's an error, we are logging the message ID so that when we go to our error logs, we can correlate the error with the message ID that we find in the delta queue, or some kind of an event ID, if you like. And that's where having good observability really comes in. And observability, people's got different definitions, and the best definition I found is that observability is a measure of how well the internal state of your application can be inferred from the external output, things like logs, traces, and any side effects that it may have caused, things like a data being written to a DynamoDB table and so on. And within AWS, there's also a distributed tracing solution called X-Ray, which I'm sure many of you would have heard of or are using already. So to test how well X-Ray deals with all of these different messaging services, I put together a little demo app which looks a bit like this at the architecture level, where you've got this API Lambda function. It's going to put messages through a whole bunch of things: SNS, SQS, Kinesis, DynamoDB streams, and Event Bridge, and you've got S3 here as well. And there's also a SNS to SQS to Lambda function at the top there. So I want to see if X-Ray is able to trace all of these messaging services, so that I can see my two Lambda functions all my Lambda function invocations in a single transaction. Unfortunately, it turns out X-Ray is not able to trace through most of this. So what should have been one transaction end up from the user's perspective, at least, end up producing 6 different traces. And the reason for that is because X-Ray is not able to trace through the popular messaging services like SQS and Kinesis or DynamoDB streams, and it doesn't trace through when you have a function putting an object into S3 that triggers another Lambda function and so on, which obviously is going to make the debugging a lot more challenging if you can't see everything in one place, especially when you consider that X-Ray has got a pretty aggressive or rather conservative default sampling rate of 5% for everything over 1 request per second. And the fact that most people rely on their logs for troubleshooting also means that you still need to have some solution to link the logs from all these different Lambda invocations together using things like correlation IDs, and having to figure out how to pass the correlation IDs from one function to another through, say, Event Bridge, through Kinesis streams, and so on and so forth. And I think that's where some third-party vendors like Lumigo can really add a lot of value. And this is the same transaction that you see in Lumigo, where all the different components in the transaction is present and accounted for, including your SNS to SQS to Lambda function action there, which, as far as I know, no other solutions can support. And you also have DynamoDB and Kinesis streams and Event Bridge here as well. There's some weirdness around the S3 to Lambda function where it's sitting in its own island, but that's something that apparently is a known bug in the Lumigo, and they're working on it. But ultimately, they're still in the same transaction view at least. And the nice thing about Lumigo is that it also shows all the logs from all your Lambda functions that's part of this transaction side by side with the visualization. So you don't need to do any correlation IDs yourself, and you can still see all the relevant logs in one place at a glance. And then if you want to sort of drill into what happened during this transaction in terms of trying to figure out why there's some error and being able to infer the internal state of an application, you can click on the Lambda icons so that you can see for any of the Lambda invocations that's part of this transaction, the invocation event. So you don't need to write console.log JSON stringify event anymore, which I see people do all the time. And you can see the return value, you can see the environment variables, any log messages from this invocation, and so on. And this is all automatic. There's no manual instrumentation. Lumigo just collects all of that for you out of the box. And if anything that your function calls, like sending message to EventBridge, Lumigo will also trace that request. So you can see that in the console, you can click on the EventBridge icon. You can see the request to the service as well as the response. You can see the full HTTP headers and body and so on. So being able to see this request and response body is very, very useful for me in terms of understanding the state my application was in at the moment when that request was made, which again goes back to observability, being able to infer your internal state for your application. And I think the biggest value that Lumigo adds is just the fact that there's no manual instrumentation. You don't need to change your code to track anything. So I'm using the serverless framework. So for me, it's literally a case of installing a plugin and then add the configuration so that I pass my API token for Lumigo into the project somehow, and just deploy, and everything will just work. You can also do the same thing with CDK, or install the tracer yourself, or just enable tracing on the Lumigo console. And as you've seen as well, it supports all of these different messaging services a lot better than X-Ray. Nowadays, Lumigo supports containers as well, but I'm not the right person to really talk about that because I don't work with containers a lot. But I do know that as far as serverless goes, I think Lumigo is the best availability tool out there. So going back to the question that we had, I kind of posted at the start, which messaging services should I be using, and how to make that choice based on my workload requirements. Turns out somebody else actually did a really nice graph and did most of the work for me. And so Magic here put a really good decision tree, and it's pretty much in line with how I think about these services as well. Like, you should use Kinesis for high volume messaging, and use EventBridge where you need to have archiving, and you need to have event replays. Although I will probably slightly disagree with his description for this last step here, because if I'm publishing an event, then I shouldn't have to care about how many consumers there are. But often when this question really boils down to is really asking if the messaging you're sending is a task or an event. And I think it's worth making the distinction here as well, because an event is you saying, hey, something happened and here are the details. Whereas a task is you telling someone that, hey, please go ahead and do this thing. And here's the information you need to do this thing that I'm asking you to do. So a task has a very specific target or recipient in mind, which is why you never have multiple subscribers to a single SQS, because when you send something to SQS, you expect some specific thing to be done, not some random outcome depending on which subscriber has picked up the message. And you often expect some answer as well when the task is done, so that you will often see things like a callback patterns being used here when you're talking about messaging, task-based messaging. Whereas for an event, the publisher really shouldn't have to worry about who is listening to this event, or if anybody is listening to this event. My job is only, as a publisher, is only to tell the world that something happened. So as Magic says here, this chart gives you about a 90% chance to make the right choice, but there's still a lot of room in there for that leftover 10%. For example, what if you need FIFO? And then when is it ever the right time to use something like DynamoDB streams? And so to help you find your way in that last 10% of use cases, I've also put together this quick reference sheet for the services that we talked about today in terms of if they support ordering, batching, and the primary cost model, and how they interplay with Lambda concurrencies and so on. So all of these are different trade-offs that we need to think about. But you can also think of them as different Lego pieces that can be combined together to achieve something to great effect. For example, if you've got a use case that needs ordering, it needs archiving, it needs replays, and you want to maximize the concurrency, and because this is not a high volume thing, so you're happy to pay per request. EventBridge ticks most of the boxes, but it doesn't support ordering. On the other hand, you have SNS FIFO, which gives you ordering by group ID, but is missing archiving and replays. So perhaps you can use the two of them together to get what you need. The question is, and I've been asked this quite a few times by students, do you put SNS FIFO before EventBridge, or do you do it the other way, to have EventBridge before SNS FIFO? The thing is, both of these are wrong. Because if you put SNS FIFO after EventBridge, then because EventBridge doesn't support ordering, then you're going to lose the ordering when the messages are forwarded from EventBridge to SNS FIFO. And the same thing happens if you were to SNS FIFO before EventBridge. Then by the time you process the messages from EventBridge, which doesn't support ordering, you're going to still lose the ordering when the messages are actually delivered to your Lambda function that need to do something. So this is how I will actually do it, to use SNS FIFO as the message service, as a service that ingests the event. And because you can't subscribe Lambda functions to SNS FIFO directly, so I will have SNS FIFO going to SQS FIFO and then to a Lambda function for any workloads that need to process message in order. And then for everybody else, I will still have SNS FIFO broadcast to EventBridge, so that anybody else who's in the system who doesn't care about ordering, just care about some event happening, they can still subscribe to the event through EventBridge. And again, if you have another workload that has got a high volume requirement, where you need batching and you need something that's more cost efficient, so you want to then pay for uptime, then the Kinesis is a great choice. But as you're processing this event from Kinesis, you can still use EventBridge, so that your Lambda function that's triggering state changes in the system, you can send the domain events to EventBridge, so that other systems that are in your overall architecture can consume these events, and they don't have to know the fact that you're using Kinesis and Lambda in your service, but all they care about is that some event happened in this application, like user is registered and so on and so forth. And even though all of your services might have some event-driven thing going on, then they can use different messaging services for their own workload. They can and should still exchange and react to events happening elsewhere in the system through EventBridge. And so, EventBridge is still going to be the heart of your event-driven architecture, even if you're using different messaging services for specific workloads based on that workload's requirement. And so that brings me to the end of the presentation. I hope you enjoyed this and found this useful. If you want to learn more about how to build serverless applications that are production ready, then check out my upcoming workshops at productionreadyserverless.com. And again, I want to thank everyone for your time this morning, and I hope you enjoy the rest of the conference.
Thank you so much, Jan. That was a very insightful session. And thank you so much for sharing your incredible experience with us. And let's check out some of the questions that we have on the screens. Okay, so the question that we have is, how can I handle payload for more than 256 KB in EventBridge?
Yeah, you write the payload to S3 instead, or something or somewhere else, and then in the event you would include a pointer to the S3 object.
Okay, is there any other way? Because one of the attendee has asked if there is any other way of doing it.
There's other ways to do this, but I think S3 is probably the most the easiest thing to do. You could also write them to DynamoDB, but DynamoDB has got a 400 kilobytes size limit. So for anything, so events that are really big, like 256K, then kilobytes, then I think S3 is probably that makes sense. That don't have to worry about the size limit anymore.
Okay, great. So we have another question. As EventBridge does not guarantee ordering, what are the ways to handle if ordering matters for consuming services?
Yes, like I said, put towards the end of the presentation, you put something else in front, like SNS FIFO, something that supports ordering, and then you do all the processing that requires ordering of SNS FIFO, and then have the event also get forwarded from SNS FIFO to EventBridge for everybody else who don't care about ordering.
Okay, so let's see if there are any. How to handle at least one-time delivery of EB?
At least one. So by default, EventBridge is at least once. So you don't have to do anything there. And if you need to do exactly once, then you have to do something yourself. So what oftentimes people do in order to make sure you got idempotency and all that is they will use something like DynamoDB, so that when the event is triggered, you write something in DynamoDB to record that I've processed this event. So the next time you get the same event in the event in your function, then you can just check, okay, have I processed this event already? I mean, the first thing you want to do is, if you can, is try to implement the idempotency. But a lot of time it's very difficult to do. So this is kind of the usual fallback you would do if you can't guarantee idempotency. And this is not just a problem with EventBridge. This at least once behavior is all async invocations for Lambda is always going to be at least once. So that's all going to be like a small percentage of invocations that just gets duplicated. Same thing with SNS, same thing with CloudWatch events and things like that as well.
All right, thank you for answering that. Let's see if there are any other questions. I think questions have ended.
Okay. No
Thank
worries.
you so much, Ian. That was a great session, and we really learned a lot from you today. And if there are any other questions, we will pass on to you offline. So if you can join the YouTube, and if you can answer that in the chat box, that would be great. And thanks again for joining.
Sounds good. Take it easy, guys. Bye-bye.
Bye. All right, people, that was an amazing session. I hope you really enjoyed that. It's time for the quiz now. So we have seen some wonderful sessions till now, and that was the last session for this afternoon. But please stay tuned. So first, let's start with the quiz. You can see there is a QR code given on the screen. Please scan that QR code. All the participants will be given 2 minutes of time, and if the QR code doesn't work for any technical glitches, please access the website from the link given in the chat. And also, I request all of you people to join the quiz. There are some amazing goodies. So for the top, we will announce the top 20 winners. The first 5 people will get Amazon vouchers worth 2,000 rupees. The next 10 will get free subscription to Whizlabs standard plans, and the next 5 will get the t-shirts. All the Whizlabs subscription codes are valid till 15th November. So this is a great opportunity. So I will be starting the quiz in a minute. All right, people, let's get started with the quiz. And this is the first question on your screen. Right. What is the maximum number of messages you can receive from SQS in a single receive request? Right. We already have got the answers. Rachit on the first, Aishwarya Sood on the first, second, Manya on the third. Amazing. All right. I see Aishwarya again leading this leaderboard in the second position. All right. Yeah, the time's up. So let's see. So 24 participants have answered it correctly, with Rachit leading at the top, and Aishwarya Sood at second, and Manya at third position. Let's go to the next question. And here it is. How long can Kinesis keep events in a stream? 1 day, 1 month, 1 week, 1 year? We have we have 15 seconds to go. Ashish Kumar, we see a new name on the leaderboard. Tushar, Utkarsh on the third position. 5, 4, 3, 2, and 1. All right. So 13 participants, 14 participants have given the correct answer, and the correct answer is 1 year. And we have Ashish Kumar on the top, Tushar Sublake at the second, and Utkarsh at the third position. Let's go to the next question. And here it is on your screen. Can you subscribe to a Lambda function to an SNS v4 topic directly? Yes or no? All right, we have 18 seconds more. We have a new name on the screen, on the leaderboard. Okay, Utkarsh Tiwari, Ashish Kumar on the first. 3, 2, and 1. Amazing, guys. So the it is no. Can you subscribe to a Lambda function to an SNS v4 topic directly? No. Let's go to the next question. And this is the final question of the quiz. And this is on the screen now. Does EventBridge support replaying events? Yes or no? We have 20 seconds to answer, and your goodies are waiting for you. You don't have to miss that. Ashish Kumar at the top, Utkarsh Tiwari at the second, and Tushar Sublek at the third position, and Kunal Rajesh at the fourth, and Meet at fourth position. Top 5 who have answered all the questions correctly. "75 participants. Amazing. All right, people. So I am going to end the quiz now. And yes, so that was an amazing quiz. And this is the lunch break now. And It's from 1:15 p.m. to 2 p.m. And please stay tuned because the sessions have not ended yet, and we still have a lot to go here. And after the lunch, we have a main quiz, that is a main quiz of AWS Community Day. The quiz will be running on track 1. Please feel free to join there and play the quiz. And after that, we are going to announce the winners for Osimify Hackathon. And later, we are going to continue with exciting sessions. And see you all at the quiz.
You can come on the. Haripriya, are you there?
Haripriya,
Okay, I guess. Okay,
yeah, she came.
okay. Let's yes. Perfect. Thank you.
Just a second. Nipun, can please come back?
Sure, sure.
I'll take a screenshot of this. Thank you so much, Nipun.
Hello everyone. Hope everyone have finished their lunch and also attempted the quiz 1 in track 2. And also I congratulate the hackathon winners. Without any further delay, let us invite our next speaker, Gaurav Kumar. He is a technology enthusiast with proven expertise in big data platforms, DevOps, and Linux platforms. He is currently working as lead head of engineer in NatWest Group. Gaurav will be speaking about data-led mesh. Yeah, let's welcome Gaurav. Gaurav?
Seems like some technical issue is there with the Gaurav.
Okay. Okay, meanwhile, let us play the Corologics video. Corologics is a platinum sponsor for our event.
Of the many challenges facing businesses today, translating ever-growing data volumes into useful information and meaningful insights tops the list. For years, companies had a choice. Either spend huge sums to index their data and suffer poor performance and low scalability, or limit data coverage to improve costs and performance and risk losing critical visibility in the process. Today, with data quickly outpacing revenue growth, leaders need a better alternative. It's why businesses of every shape and size partner with Corologics, the next generation full-stack observability platform that provides infinite insights for logs, metrics, tracing, and security data when and where you need them. Setting Corologics apart is our Streama technology that ingests and analyzes data in-stream with no reliance on storage or indexing, meaning all of your data can inform every aspect of your product, operations, and business. Put simply, Corologics' next-generation architecture is built and priced to help you make sense of ever-growing data, not squeeze your bottom line as you scale. Let's take a look at how Corologics can fundamentally reimagine how your business leverages your data. To get started, simply send all logs, metrics, tracing, and security data to Corologics using open-source shippers and collectors. From here, the possibilities are endless. Transform and enrich your data to better inform your business. Create dynamic alerts to reduce false positives. Even convert raw logs to metrics without ever indexing them. And that's just the beginning. Our powerful self-serve alerting mechanism runs in-stream with no index latency or mapping dependency. Cover service-level objectives for your entire production, understanding the frequency and extent of incidents. Trigger alerts on immediate occurrences, or use ML-powered dynamic thresholds to identify unexpected system behavior. In the Explore screen, investigate and correlate events across all environments. View metric aggregations and comparisons together with version release tags for advanced data correlation. Quickly pinpoint performance issues with filters for any key or label in the sidebar and query using any syntax, including Lucene, SQL, and our Data Prime with on-the-fly joins and extractions. And to give our partners an edge, machine learning algorithms within the stream automatically cluster tens of thousands of records into unique log templates, all of which allows you to drill down into behaviors and variable distribution to identify issues before they become problems. In the Actions dropdown, quickly navigate through the UI or jump to any other third-party system for seamless issue resolution. The Tracing UI provides powerful filtering and aggregation capabilities to easily identify latency for any application, subsystem, service, or action. For further investigation, drill down into any trace to view the spans with relevant logs and metrics to see a dependency map in a single click. For an even deeper understanding of your system's health, build custom mapping visualizations of your metric data to represent limitless perspectives of the structure and behavior of any application. Click any element in the map to investigate further with a 24-hour graph of the metric together with its assigned thresholds. And to ensure you extract maximum value from your data, our next-level customer success group, made up of world-class SRE and DevOps talent, serves as an extension of your team. ready to respond in under a minute 24/7 to keep your systems and business on track. No matter what tomorrow will bring for your business, Coralogic's platform is there as a partner to unlock more value and endless possibilities from your ever-growing data.
Right. Before I begin, just wanted to get a quick confirmation if I'm audible. Right.
Yes, you're audible and your screen is also visible.
Great. Thank you. All right. So let's start talking about data mesh and data lake. So not very long ago, the world started their data journey with data warehouses, then to a world of Hadoop, which was a major buzzword in late 2010. Almost touted as a father of modern data lakes. I'm here to talk about some of the unfulfilled promises of modern data lake and how data lake mesh tries to improve the situation a little bit. A little about myself, Gaurav Kumar, working as a principal engineer at NatWest, leading a data lake cloud team for the bank. Total 11 years of industry experience, worked with AWS, Teradata, Bank of America, Reliance Jio as well in my stint. Primarily worked on system administration, have managed big data platforms, now creating solutions in the world of data. So before I begin, I'd like to thank everyone for arranging this and such an informative session and giving me the opportunity to present as well. Now, without further ado, let's talk about what am I going to talk about today. So the agenda is pretty simple, and I would like to gradually take it further up a notch, describing and talking about what data lake is, because in order to understand data lake and data mesh, we'll cover about data lake, problems of the enterprise lakes today, what data mesh obviously is. I'll be talking about lake formation in the same spirit because of my experiences in the industry about lake formation. I'll be talking about how does lake formation improve data lakes or kind of enrich the functionalities of data lakes. We'll be talking about how enterprise adopt lake formation in particular. Right, so before we talk about data lake, let's try to understand what data lake holds, right? It holds big data. And what is big data? We all know the 3 V's of big data: volume, variety, and velocity. So a simple definition to it, in my terms, would be data that is unable to fit into traditional systems. That is big data. And you put this into a lake. What is a lake here? It's a value-driven data repository for all kinds of your data. So structured, semi-structured, unstructured, and things like that. What avoids making data lake a data swamp is perhaps a repository around what data you're hosting in that lake, and with some sort of schema on top. And that schema can be flexible in nature, which is what we have been studying about it, schema on read, for example. So that's data lake in general, a quick introduction about it. Why do you use it? Why do you use data lake? So some of the real applications, real world scenarios and applications of data lake. You got machine learning, artificial intelligence, business intelligence tools, visualization, real-time analytics, some of the applications that we all know. What does it really help in? Well, it helps for starters, it helps in the revenue growth, because obviously money makes the mayor go here. It helps you create better products, better experiences for your customers, because if you belong or if you're running any business, you primarily will be creating some sort of products for your end users. It helps in business expansion, obviously, with revenue, with growth, you can expand your business, so business growth. One of the problems with businesses, enterprises these days is retaining your customer base, right? So how do you retain customer base? So with growth and understanding and providing better opportunities and better products, you can retain your customers. And how do you retain them? Is by making better decisions, which obviously is a byproduct of these data lakes, which help you analyze great deal of data, which, data being the revolution today, it helps run businesses efficiently. Then I'd like to talk about who are the biggest beneficiaries of big data. And you might be surprised that I've mentioned financial and security services. On the top of your head, you might think that it's social media and communication, but you will be wrong there, because upon my research, I found that some of the biggest industries which are benefiting from big data are actually financial and security services, because obviously these are heavily regulated industries and would like to curb any fraudulent transactions or any activity which may not be aligned in the best interest of the world. So financial and security services, followed by social media, communications, sports, energy. What I've not mentioned here is who also benefit from big data is the mainstream politics. They also take quite a great deal of value out of analyzing big data and understanding your sentiment and our sentiments. And you might be surprised that you may not know about yourself as much as the world out there and the platforms out there. Right. So with that information, let's try to understand a little bit about the problems of the modern data lakes in general, what we see today. So let's start with monolithic and centralized. So obviously, having covered about data lakes, we can all understand that it probably is a place where you keep a lot of data and then you try to analyze it and generate some insights. But more often than not, they become monolithic in nature and centralized. Why? Perhaps you keep on dumping data into a central platform, and let's say your data lake or the services that you're providing as part of your data lake is down. That inevitably is going to impact your downstreams. So that being one of the problems that I can think of. Obviously, with this being monolithic and centralized, you have scaling and data proliferation issues as well. We've seen that data lakes, the journey of data lakes, it started with probably Hadoop on-prem, and then in cloud, you may think that scaling might not be an issue, but there are other sort of scaling issues that you may soon hit, because obviously, let's agree that scaling cannot be infinite in nature, right? So scaling does become a problem with the modern data lake platforms. Data proliferation, because you are now trying to grow your business, you're trying to retain customers, you will be feeding data to your big data monster here. So data proliferation becomes a big problem. How do you manage ever-increasing volumes of data? Then security and compliance, obviously, you've got a great power. Data is the power today. So responsibility will be depending upon what kind of industry that you represent. Security can be of paramount importance here. So security and compliance around what kind of data it is, whether it's sensitive nature, secret data, and things like that. The last problem is around siloed ownership. And just to give you an example, so because I have been managing big data platforms now, leading teams and creating solutions, you'll see that there's a fleet of data platform engineers trying to maintain a huge or a big data platform, which more often than not creates problems, because it could be tunnel vision of the platform engineers, or there's always that constant drift between data platform engineers and data product teams, for example. Right. With that, let's try to understand how typical enterprise implement their data lakes, and how does it really look like. So in a nutshell, I think this diagram could be pretty common industry trend. How do you create enterprises? You have a big data platform, you have a data lake, and you obviously have a all right, I think these are probably questions. Let me address them towards the end. So you talk about data lakes, and then you think about, you obviously have a dev, test, prod life cycle of your data lakes, and what happens with them is that there might be some use cases, because we've spoken about machine learning, artificial intelligence, and what do they all have in common is that you need data where you can perform some analysis, right? So the first point that I've mentioned here is development and production for ML use cases or any sort of analytics. They happen more often than not, they happen on a centralized data lake, so that can be a problem. Then you've got lower environments, right? Dev and test for your dev, test, prod lifecycle, which are not consistent with production data lake. And these are some of, I'm reflecting upon my experience of the industry and how I have created solutions and seen solutions in the real world out there. So yeah, that potentially, we'll talk about how this can be a problem and try to stitch it back once we further go into this discussion. So the test and the learn cycles obviously will be demanding your full scale of data, ML, AI, as we discussed, and they can become complex, when you put governance and security requirements around your data into the same context. So that's a big challenge here, and we'll try to understand how we can solve that. The last but not the least is sharing of data, right? So you've got this big data lake monster, as some people call it. You want to share this data with, let's say you are part of an enterprise organization which is growing rapidly. You got data coming from different domain teams, line of businesses, franchises. How do you share that data, towards reaching a common goal, for example? So that will happen when you facilitate some sort of data sharing between your different line of businesses and avoid creating a centralized big data platform. So obviously, that being a challenge, we've already discussed about some of the problems with enterprise data lakes in general. So sharing becomes a problem, and also the data gravity, right? So you got data lakes, you got data warehouses, shifting data from left to right to left, all sorts of, for managing all sorts of use cases. So that's a big problem to manage, right? With that, let's try to understand how data mesh attempts to simplify things a little bit. But before that, let's talk about what data mesh is. So data lake with data mesh, that's been my topic. The four major principles, and I've explained them in the terms and in the context of how I have implemented them and how the industry is going to implement them. So the four major principles, you got domain-oriented thinking, right? So each ecosystem, for example, creating and consuming data that can scale out, and number of sources of data that you have can scale with the domains. So number of use cases that you're catering to can be dealt with a domain-oriented thinking. Moving to the next one is data as product. So so almost treating data as a commodity, which can be shared between these different domains. And the good thing about data as a product thinking is that you need to maintain some sort of standard. So obviously standardization is kind of important here. So your data becomes easily discoverable, understandable, and it is secured. And it's a high quality data, which creates a delightful experience for whoever is going to consume that data. So data that is distributed across many domains. So that's the data product thinking. Third one is probably my favorite as well, because of the nature of the job that I do. I'm managing a big team today. So self-service data infra platforms, so that your domain teams, they can create and consume data products and almost have a abstraction of the platform. Don't really have to worry about how do you manage your platform. So what I like to interpret or think about self-serve data infra is almost creating a template of your data lake. But we'll talk about more of that in the next slide. Centralized governance, slightly tweaked version of what Zamak introduced data mesh as back in 2019. So I like to centralize the governance, but at the same time, we'll try to understand how governance in particular plays a role here. So basically, it's the data that you can use for aggregation and correlation for multiple data products and keeping it secure and governed at all times. That's what centralized governance is talking about here. Now, in terms of implementing these principles in the context of implementation in particular, again, reflecting upon my experience and what I have seen and witnessed in the industry and have done myself. The first one, the domain-driven data architecture. So basically you have a source of data, the ingestion of data into particular domains, and that is owned by different teams. So let's say you got a central data lake team, and you need to provide capability for your, let's say, spoke teams or application teams. So there might be a construct where, depending upon the size and scale again, so it all depends upon the kind of industry that you're coming from. So data resides in, let's say, a central data lake over a series of buckets, and that can be broken down into domains and enterprise. So let's say you are part of an enterprise team, you publish some data which will be used across your line of businesses. So you become that hub kind of team which manages publishing of the enterprise data. The whole ownership of the enterprise team is now to maintain this data and almost treat this like a product, right? The second one being business domain data. So I'm bifurcating, segregating this according to the responsibility of the business domains. And then you can, in the same vein, you can imagine, depending upon what kind of industry that you're coming from, you can segregate different domains. Moving on to data product thinking. Now your data is made available through a central catalog in the context of AWS. And since I've seen the journey for many financial services predominantly using AWS or other cloud service providers. Now, in the context of AWS, when you catalog that data, I'm not supposed to mention technologies, but let's, for the larger understanding, that catalog being Glue Data Catalog. So you made that available through Glue Data Catalog, which is of certain quality and standard. Now, data is maintained in column-oriented, file format, for example, using Parquet. That's primarily because Spark likes it the most. So better results using file format as Parquet. The management of data product is owned by business domain teams and enterprise domain teams, which are populating it. So basically, they have the responsibility of cataloging that data and making it discoverable, trustworthy, governed at the same time, so that different teams participating in that data lake can discover that data and get benefit from that data. Obviously, the access is a major point here, which we have spoken about being a contention in the modern data lakes. So access is managed through a centralized, almost like a different service, an entity. Let's call it as access management service. In the world of AWS, that is AWS Lake Formation, which conforms to some of the security standards that you as an enterprise or an organization want to lay for your clients, that they can access what sort of data. Third one, self-service data platforms, through the use of ISE, infrastructure as a code, and Terraform being hot off the press and predominantly widely used in the industry. So it gives you that standard and practice. Basically, as a data platform team, you can build that abstraction for your data product teams to not really have to worry about what happens under the hood. So you can almost create a template which can be cloud agnostic, right? So that's one of the key requirements of your data lake, adhering to data mesh principles, and something that Zamak quite recently mentioned in her talk at the Big Data London event, which I recently went to. So trying to make your data lake or data mesh platform cloud agnostic and any service agnostic as well. So you don't really have to use a particular data lake solution at all times. That's not really data mesh, and that is probably against the principles of it. The computational governance part, so centralized and governed way of operating your domain, which can be shared, ensuring compliance and security standards of your organization. And the service that probably helps here, and I was quite keen when Zamak mentioned about lake formation in the same vein. So I've picked up few of her talks and explanation around computational governance and use of lake formation in the industry, which helps ensure that data is securely accessed. Now, all right, let's try to talk about lake formation now, because we've been talking about lake formation quite a lot. So before we see things in action, I have a diagram, an architecture where you can see things in action and how they are implemented in the industry. So what is lake formation? So obviously it's a fully managed service by AWS. You don't really have to pay for this, but obviously you'll be paying for things that construct or are a part of lake formation as a single bundle. What it helps you in with the very first thing around data lake enterprises, you collect data from multiple sources, right? Clickstream, SQL data, or unstructured data, or any kind of data, social media data. So collecting that data becomes quite easy with lake formation. Second step is cleaning that data. So cleaning that data and moving it to a catalog, basically cataloging that data. So when we spoke about making it discoverable and things like that, that's the cataloging stage. Third one, securely making that data available for your end users, right? So that's most important here. And in the same way, sharing that data. So the last part is basically what I think is where lake formation excels at: sharing that data and securing that data for multiple use cases and your downstream consumptions. Cool. So how does it work? We'll talk about some high level understanding of how lake formation as a service really helps and how does it work here. So very first thing, I hope you're able to see the diagram. It's been taken from AWS, just to try to play the context right and create an understanding about how lake formation in general is going to work. So register a data lake. That's the very first, the basic step. Then you orchestrate data flow ingestion, right? So you register a data lake or an S3 bucket in this case, which will be under the control of lake formation, and then you start ingesting data into it. You'll have to create some sort of workflow so you can understand the registering part probably happens somewhere within the data lake itself. The orchestration can be abstracted to a separate service, let's say Glue, for example. So you can orchestrate, create your workflows and start ingesting data. Then you create and manage a data catalog containing the information about what data have you published, right? So that's probably, if in the diagram, if it is visible to you guys, you can see the data catalog. This is where, again, a bundled service within the Glue ecosystem. Glue data catalog is quite important here for how lake formation in general works. So you can almost treat that this service encompasses the Glue ecosystem in particular, and also to some extent things like KMS or your S3 bucket. And then towards the end, once your data is cataloged, it is present in the Glue data catalog. You define granular level permissions. Granular level permissions on how your spoke teams can access this data. Right, so let's understand the enterprise implementation of it. So it's a 4-step process. It's very simple in the context of implementing it. You've got, let's say, a production data lake, a test data lake, and dev data lake. And we spoke about some of the challenges around production, test, and dev data lake. I think I'll be okay. I'll just quickly finish this part. So you got the Glue data catalog, the lake formation as service encompassing it, and you've got S3 buckets, you different enterprise data, line of business data, and then your consumers like EMR, Athena, Sagemaker. And how do you share that data? Sharing of the data is facilitated by what, in the context of lake formation, are resource links. So basically either share the resource at a table level or at a database level. And now this data is now visible within your test and dev data lake. So you don't really have to gravitate or shift the data gravity towards test or dev data lakes. You can easily, using the resource links, you can then consume this data in test and dev environments, which becomes very easy for management purposes. Now let's take it a level up. This probably is the last leg in what I want to talk about. You got these multiple data lakes. How do you now join all of them together, right? So I'm talking about your data, your organization requirements where the business is growing and you have multiple data lakes now. How do you now federate them? How do you join them all together? That's what I meant by the central governance here. So you got all sorts of data lakes joining together through a central governance. So let's say your line of business 1, line of business 2, or let's treat it as franchisee. So if franchisee 1 and 3 wants to access data, so basically request through the central governance account. You create a resource share link, which can be then consumed. So in the context of lake formation, you'll have producers and consumers. So your franchisee 3 is almost like a consumer, right? So once the resource share has been published, made available for the franchisee 3, they can consume it via services which are compliant with lake formation, such as like EMR, Athena, Sagemaker in the same vein, and so on and so forth. So I think with that, this probably is the end of what I wanted to talk about, how lake formation in general helps and is rapidly evolving in the industry, and the adaptation to lake formation has been quite enormous. Thank you.
Thank you so much, Gaurav, for the insightful session. Hope all the attendees have enjoyed equally along with me. And we have few questions aligned up for you. Okay, this is from Gaurav. You talked about financial and security services. As part of data governance, I have a use case of data delete for a specific customer from data lake. Do we have ready-made solution in AWS?
Yes, I think we do. So you want to delete some data specific to a customer in data lake. So I think that's where lake formation really helps. So you can grant permissions. As I mentioned, lake formation helps you grant SQL sort of statements in managing your access. So you can actually give access where different domain teams have full control of the data that they're publishing, so they can alter it, almost execute CRUD-like statements. So create, update, delete, or insert. So that is easily possible through use of services like lake formation.
Yeah, thank you. The next question is from Abu Tahir. While using data lake, don't we need any processing of data from outside to provide it as an input to ML or DL models?
Yes, we do. And that's the data engineering part of it, right? So your data lake kind of subsumes the responsibility that you have a data engineering team or a data product team, which is responsible for providing that data as a product. So that will be, obviously, inevitably, will be your data engineering team. They will pre-process that data, make it fit for training and development for a machine learning model before you actually start running models on top of it, because otherwise, how inefficient would that be if your data is not of a certain quality standard and you start training model against it? So it doesn't really generate any business insight. So obviously, that's a prerequisite of how you host a data lake.
Okay, thank you, sir. Okay, yeah, there is another question from Ankur. Nowadays, customers prefer transactional data on the likes of Apache Hudi or Iceberg. Can I leverage data formation to handle Apache Hudi or Iceberg?
I think that's a really good question. And within the ecosystem of lake formation, we have seen, so basically, let's understand what Apache Hudi and Iceberg are all about. So we are slowly, steadily migrating towards a lakehouse trend, right? Where you can almost query your data in a SQL style manner. Well, some people might argue that that's not what data lake is for, but the industry has now started adapting towards SQL as the global language of interpreting, analyzing your data. So these are basically table formats, Apache Hudi and Iceberg, which gives you asset compliance. Within the context of lake formation, you have managed tables, which gives asset transactions to the data that you're publishing to the lake. So yeah, it's pretty much possible, but to be honest, I haven't really seen a lot of people using it. But the trend around Iceberg or Delta is probably catching up more. But yes, it is available natively within lake formation.
Yes, another question for you. Okay, how would you compare data mesh concept to a lake house? I see it is another pattern recently emerging.
Yeah, absolutely. So I think I just spoke about it in the previous question as well. So Lakehouse basically gives you an ability where you can almost join up your organization, and the rift and the divide that we see between data lake teams and data warehouse teams is kind of joined up with this Lakehouse approach, because now you have a very powerful tool called, or a language called SQL, through which you can query your data, not just within data lake, but also within the warehouse. So the lake house as a concept kind of facilitates data sharing between a lake and a warehouse, which is what lakehouse represents here.
Okay, thank you so much, Gaurav, for answering all the queries. Yeah, so you can also join our YouTube stream and also comment for all the questions. Okay.
Thank you.
So that
Thank you
will
so
be,
much.
yeah. Thank you so much, Gaurav. Okay, everyone, let us start the quiz. So we'll be giving a breaking period of 2 minutes so that whoever haven't signed up into Quiz Hub, they can. You can redirect to Quiz Hub using a link which is pasted in the comment box, and also by scanning the QR code. So there are full prizes giving for the quiz tournament winners. We are taking top 20, and for first 5 we are giving Amazon vouchers for rupees 2000, and for the next 10 winners we are giving free subscription to Whizlabs, and for the next 5 we are giving t-shirts. So please do win in the tournament and get these cool swags. So without any further delay, we'll be sharing my screen and we'll start the quiz. Okay, we have 238 participants. Let us see who tops the leaderboard. Let me start the first question. Hope everyone is able to see the first question on their screens. Which one of the following is not an AWS continuous integration or continuous delivery tool? AWS code deploy, AWS code commit, AWS code build, AWS commit. I can see most of the people have already answered. You're coming to the end of the quiz. The time is getting up. Please do answer. Okay, let me check the stats. Oh, that's great. So 51% of the people have attempted the correct answer. So let us jump to the next question. Yeah, the second question is, which one of the following service cannot be integrated with the continuous delivery pipeline with AWS code pipeline? AWS Lambda, AWS S3, AWS Git Central, and AWS OpsWorks. Okay, now Anjana Gopalan is the top position for the leaderboard. The time is running up. Please do answer. Yes. Let me check the stats for the second question. Okay, only 10 participants have answered it correctly. Now the explanation is there is no such tool or service for AWS Git Central Reference. So there is a reference given here. Yeah, let us jump into the next question. So the third question is, you are working on a software application for which you want to set up a deployment service. Along with it, you want a detailed report to view when and to where each application division was deployed. Which one of the following services will allow you to do that? AWS Code Commit, AWS Commit, AWS Code Deploy, and AWS Code Build. Okay, now Anjana is on second position and Suryadeep is on first position. Okay, the 60% of the participants have answered correctly. So the explanation is AWS Code Deploy gives you a detailed report allowing you to view when and to where each application division was deployed. Okay, this is a final question. So with this question, we get to know who tops the leaderboard. The question is, which of the following application specification file is a YAML formatted or JSON formatted file used by Code Deploy to manage a deployment? Okay, Suryadeep is on top position. Yeah, congrats, Suryadeep. Okay, let us see the stats for the final question. Okay, 39% of the participants have answered correctly. Yeah, thank you everyone for participating in the quiz.
All right, people, that was an informative session and a great quiz. Let's not keep our next speaker waiting. For the next session, we have Pawan Gumaste. He's a cloud architect and enthusiast in developing platforms. He is currently working as a product manager at Whizlabs. Pawan will be taking us on his journey on migrating from server to serverless, the Whizlabs story. Please join me in welcoming Pawan to share his experience. Over to you, Pawan.
Hi, everyone. So, can you confirm if you can hear me?
Yes,
Hello?
yes, we can.
Okay, fine. So, hi, everyone. It is really nice to be here in this AWS Community Day event. And yeah, so myself, Pawan Gumaste, and I am a cloud architect here at Whizlabs. And I am also a platform developer and a technical product manager. So I am working on new product development for Whizlabs. So we develop on hands-on labs, practice tests, and different things. So I'm looking into all the platform development related things to it. So yeah, so before starting our server to serverless journey, I want to just showcase like where I have started my journey and how these AWS Community Day events have been very helpful for me in going from serverless to serverless. Yeah, so in 2017, I started the cloud-related setup, and I started working on cloud-related services. So I was mainly working on application development, infrastructure development, and new product development. So I was always hearing about the cloud-related services, so got into it. I understood a lot of server-related stuff like EC2 and RDS and things like that, and I started implementing these things. So then I attended the AWS Community Day event in 2018 in Bangalore, and that got my attention towards the serverless because I attended the sessions which are helping me to understand the serverless and GraphQL. So these were the things that were coming at that time. And even though I heard about these services, I was still skeptical about these things, and I was very much not aware of overall how it is going to work in the production environment. So the Community Day event which I attended, so you can see some of the images which I have attached here. So I attended the Community Day event, and thanks to these community day events, I am able to get into the serverless and move Whizlabs, my company, into the serverless world. So thank you so much for the organizers for all these years for organizing many sessions which are helping out all the participants. So as a participant now, I have become a speaker, which is I'm very happy to say that these things are helping me out. So yeah, let's move into the today's agenda. So we are going to understand, like, from Whizlabs perspective, what is the platform which we are providing. We are going to understand the types of products which we have and the type of servers which we were running. So the first part of it will make us understand the different types of servers and products which we have, and that will in turn help us understanding how we migrated from server to serverless. So the second part is where we will understand in detail each and every servers which we had and how we started migrating from server to serverless one by one project. So there's a lot of process involved in it when we started it, and there is a lot of learning curve also involved in it. So there are a lot of advantages and disadvantages, and what does the future hold. So all these things we are going to understand with this webinar. So yeah, let's go. So in terms of Whizlabs e-learning platform, we are providing online training to many certification-based courses with the practice test, video course, and hands-on labs for 5+ million professionals and 100+ companies. So we have a huge user base in Europe, India, as well as in US. So they are all using our platform to learn these things. So you can see we have AWS, Azure, Google Cloud, different types of courses are available. So remember that all these products are developed on cloud servers. The entire thing is developed on something called a LMS. So what is an LMS? An LMS is a learning management system. So this is where we have developed our entire system. So let's try to understand what is a learning management system. So our product is where you come to our platform, you start learning the practice tests, you start learning the video courses which are streamed, and you start learning the analytics of it, and you start going through the reports provided by it. So as you can see, we have the projects which have deployed all these servers. So our entire product base is deployed on cloud servers with these technologies. So what all things we have? We have practice tests, video courses which are streaming, hands-on labs which are dependent on cloud, and variety of other programming languages, and also we have the sandboxes. Now, so by understanding the number of products which we have, we will be in a good situation to understand how we have moved from server to serverless, right? So we have an e-learning platform. We have a platform as a service, that is our LMS platform. So then we have a software as a service. What is a software as a service? We have different types of cloud sandboxes. We have different types of products which are customized for the B2B clients. And we also have white labeling APIs which are used by other customers. So these are all developed on the servers, and there are the management analytics tools and learning analysis tools which are available. So remember that all these products are developed on a server. So now that we understand the products, let's move ahead and see what was our initial cloud setup. Let me go. Okay. So now you can see that this is our the first setup in the cloud. So when we initially started on the cloud, this is what we had. So from the layman perspective, initially when we started, I knew that I needed a server. So I created an EC2 server, and then I needed a database. I created the RDS database, and then so we use the public IP address and we connected it to the Route 53, and voila, the website was working. There is nothing wrong with that. So we were using a PHP technology, we are using the MySQL, we are using the HTML and JavaScript. So all these things were compatible with the server technology. So our developer used to develop a code in their local, and they used to give it to our server team. And there was no understanding in terms of what the developer were doing and what the server team was doing, because developers were purely concentrated on the feature development, and server team was concentrated on how do we deploy and where do we deploy. And then we have this model, basically what we can say it as a monolithic model, which is a highly coupled model, and it is not highly available, and there is no disaster recovery. So even though we were in the cloud, these were our initial days in the cloud. So we wanted to move ahead from this, right? So now we know, once I attended the community day session, I knew that, okay, this is what we have. We have a cloud server setup where we have a EC2. There is something like a ECS is there. There's the auto scaling is there. There's a cloud load balancer is there. There's the RDS. So I know that these are the cloud server setup which we have. And I know that if I want to move towards the serverless, these are the services which I have to use. I have to use the Lambda, I have to use the S3, the API gateway, DynamoDB, step functions. So I started reading about all these things. I understood on service to service basis. So I understood that each and every service has its own perks, and I understood, okay, so EC2 is a compute. Okay, now I can use a Lambda for it. So I know that there is a DynamoDB. Okay, so the data can be converted from RDS to DynamoDB. So there was I could correlate and understand that, okay, this is how we are going to move forward. But at this point of time, the only thing I knew is that these are the serverless services, and I did not know the production level projects, how do we move into the serverless. So in this time, I had to sit back and understand our overall objective of what we are trying to achieve here. So what did I do? I went to our entire project setup. I looked into the setup and saw, okay, when I'm saying the LMS, when I'm saying the product line, it is not just there is a one project which is deployed on one server. There are many different projects which are running, and they are deployed on many different servers, right? And it is not easy to convert them directly into the serverless, right? So now I have to sit and decide, what do I do now? So should I directly change my entire way of thinking from server to serverless? Now that is a big ask, because most of the team which is there in our most of the team which is there, so that is all completely efficient with whatever we are running now. So now I had to divide all these projects into different types. So I am dividing these things into a smaller projects and the bigger projects. The smaller projects which can be converted easily into the serverless, and more complex project which has to be migrated. Okay. So next, so this is where I understood that we have to make certain decisions here. So I have to sit and overall, I should have a broader perspective of what we have as a company and where we are moving from. So this is what I did. So I sat and understood overall our team's strength. So what is our developer team strength? What is our cloud server team technology stack strength? And what is our overall company overall objectives are? So this is very important when we are making a large-scale migration from server to serverless. So when I started doing that, first thing is, let's look at the developer team strength. Okay, we have very much proficient in PHP Laravel. We are proficient in MySQL DB. We are proficient in HTML, CSS, all of the stuff frameworks related to it, right? But I know that that is not compatible with the serverless, right? And second thing is, I looked at my serverless, my server team, and I saw that they are very much comfortable with when it comes to server setup. For example, there are 10 to 20 EC2 instances are learning with the different instances and different sizes, different RAM size. There's a lot of different things servers are there. Our cloud server team is very much efficient with that, and they are very much comfortable with that, right? So now, if I am coming with the idea that let's move to the serverless, will everybody be ready to move into the serverless? Now that's the question, because everything is there on the server, and the company roadmaps are there where we want to go. And I am coming up with a new technology of serverless. So is this possible? So definitely not at this point of time, because the developer team strength and the server team strength does not match the type of technology I'm trying to move in. So what do we need to do here? We need to upskill our developer team. We need to upskill our server team. And also we need to rethink and redraw our company objectives. We have to rethink our product delivery roadmaps. We have to rethink on the timelines for the technology upgrades. So all these things we need to do. So once that is done, then only we will be able to go forward. So what is my immediate requirement? So if I go into the first V1 architecture, you can see that it is a EC2 and a RDS. This is not a that much of a good system. So I want to stabilize this first before moving into the serverless. I want to stabilize this and make sure that there is no production issues or anything like that. So what do? I know that in server, there are some of the things like auto scaling and load balancer, which is going to help me. So we created a system wherein you make the system stabilized and it works. And it is going to help in the long run. So what is it going to do? It is going to deploy all the projects with the auto scaling and load balancer setup. You are still able to develop all the features you need. You are still able to use your server with the same technology knowledge which they had. So they still had this cloud server setup knowledge. They still had a PHP. So we can still use those developers to work on this, and we are able to implement a new cloud server setup, which was still a monolithic, but it was scalable and highly available now. So this helps us make all our projects stable, and it becomes highly available, and clients are very happy with that. So now we are doing multiple different things here. What is that we are doing? We have started doing the CI/CD process. Initially, there was no CI/CD. We started with the CI/CD process. So now that is the first step. So now what do? Once we do the CI/CD process, in the back end, you start training your developer team. So the option 1 is here. You bring in the entire serverless compatible team, which can be done. In that case, you have to completely scrap off all our development team, and you have to bring in the serverless team. So that has its own consequences, because all your development team will have a product knowledge. That product knowledge is also important when it comes to the development. So are you going to directly go into the serverless technology without that product knowledge? No, that is not possible. So we started upskilling our development team with the serverless technology, and we started upskilling our server team with all the serverless technology related services, and also we started rethinking and redrawing all our plans. So now that we are comfortable with V2, we started making the future plan. So what is that we have to do in order to move into the serverless infrastructure? So first and most important thing is you start with the microservice architecture. So this is most important for any serverless applications. So you start with the microservice architecture. This is going to help you when you are creating a serverless architecture, and it will make your life easier when you are moving forward. So now we thought about it, and we started using a serverless framework. And second thing is you start upskilling your developer team. So with respect to the front end, with respect to the back end, as well as from the database point of view, because you are changing your whole perspective from MySQL to NoSQL, and that takes some time for people to understand and get comfortable with this kind of technologies. So, and also at the meantime, our server team is also getting upgraded with their skills in terms of handling CI/CD deployments for Lambda, and also understanding the functions like step functions, event bridge, and using CloudFormation and Terraform technology for serverless deployments. So this is going to help us when we are moving further with the serverless technology. So in the back end, these training process started, and our team started understanding these things, because we divided our projects into 2 different categories. That is, one is a smaller projects, as we discussed here. One is a smaller project where we had so one is a smaller projects. We had around 5 to 10 smaller projects, which we started converting to the serverless. And this conversion of smaller projects into serverless projects, from server to serverless projects, helps us give a confidence in that, yes, the complex projects can also be migrated to the serverless, right? So now we started thinking from the long-term perspective. So now what did we do from this point? We created a big architecture. So now in the V3, what did we do? We moved further from CI/CD process into the ECS environment. So you can see as part of this architecture diagram that our cloud infrastructure is becoming more and more complex as the time goes by, but at the same time it is becoming more and more stable, and more users are coming to us. So this is making our infrastructure development as well as application development more easier, but at the same time the complexity of the cloud is increasing. So here you can see we have ECS containers, we have which are having the front end code, we have the serverless framework which is having the back end code, and we also have the Amazon Aurora RDS. So that is, we started using the RDS serverless. So what did we start doing here? So in the V3 technology, the model we started with is, let's move the server back into the serverless. So our business logic, which was completely ingrained in the Laravel, we started with that and we said, let's move that to a serverless technology. So what is one of the really good serverless technology which is available? That is a serverless framework with the Node.js. So that is the open source serverless framework. We started using it and we became very much comfortable with it. And it helped us a lot in terms of migration of our server technology into serverless in terms of middle. So we are still in the business logic level, and we started moving all the services related to it into a microservice serverless framework with the Node.js. So once that is done, we had a front end developed in a React and Next.js that in turn in future is going to help us move towards the serverless for the front end as well as in the database level. So the database level we converted it into a PostgreSQL. So now, what are the advantages of this V3 Whizlabs cloud architecture? So we have a serverless backend, we have a decoupled environment, we have all the microservices, and it is highly available, and it is have a disaster recovery. So all these things combined together, the maintenance of the things become moderate. So some of the things which needed a lot of attention, now that's resolved and everything started flowing smoothly. As far as the cloud technology stack is concerned, from only understanding to EC2 to RDS, now our entire server team is able to understand all these serverless technologies. So we started with the code commit, code build, code pipeline, code deploy. We started using the Docker. We used the Terraform for information for infrastructure as a code. And we also used the SAM, the serverless application model, which is provided by AWS. Our team is able to understand overall how the AWS Lambda works and the API gateway, step functions, and ECS and ELB. So these are all the things which were used as part of the V3 architecture, and our team is able to understand these things. They were getting upskilled, and now that we know all these things, we were ready to go into the completely serverless technology environment. So now that we have this entire architecture, we started thinking about the serverless. So let's move into the server, the V4, which is still ongoing process because there are many, as I discussed, there are many projects are there in this, and it is not easy to move everything at once into the serverless technology. So we are going everything step by step. So what did we do here? So we knew that there is a new amazing technology like AWS Amplify, which is coming up, right? So AWS Amplify is something which we had in mind, but we wanted to make sure that it should become like a production-ready kind of a technology. So for that, we needed an upscaling. So we started understanding the Amplify React.js using the React and Next.js, and we started using that for the front-end purpose. So the advantage, what is the advantage of using the Amplify? So here we can see that Amplify provides a Figma. So this is something which we were doing from the beginning. The Figma was something which we were doing for the UX design. So now that Amplify is providing the plugin wherein you can directly import the Figma, it becomes easy for our front-end development, right? So now you have to convince your team to start using the Amplify. So we started using this Amplify for our smaller technologies, smaller projects, which we were able to easily move into the serverless environment, and we were able to put it in the production environment, and we were happy with what the results we were getting. And then when it comes to the complex projects, which has LMS code and everything, so we started working on this. So this is an ongoing process wherein we have our serverless framework with the Node.js, and we have started using the GraphQL as a database. So remember that this GraphQL is something which I learned in the beginning. As I told you, I attended the community day. So I can say that the community day event has helped me in understanding serverless technology. And if our company is moving towards into the serverless technology, that's because of the events like these community days which are helping us. So yeah, so we are moving into the GraphQL, and we started using the Terraform and Docker and Amplify CLI. So here, the model which we have considered here is a serverless front end and a serverless back end, as well as a serverless database. So now, by moving towards this, we can completely say that our entire technology is moving towards the complete serverless technology. So even though I can say that the complex servers are still moving towards the serverless, there are still some servers which are still running on the server technology. That needs some more understanding when we are going into the serverless technology, because we have many projects which are like an infrastructure CI/CD, wherein dynamically generated infrastructure is there, which are running on Terraform. So how do I move the Terraform code into the serverless technology? This is something which we are exploring now, which is going to help us moving forward into the serverless technology. So here we have the microservices, we have the continuous integration and continuous development system, we have a highly available system, and there is a less maintenance compared to what we used to do. So yeah, this is our journey from server to serverless. And yeah, so the Amplify has helped us push it. It has helped us move to the serverless in a faster way compared to the beginning. So now that we are fully into the Amplify, we are planning to use this entirely. We are planning to develop all our projects into Amplify technology. So yeah, so Amplify provides all these services like Amplify Studio, Amplify CLI, Amplify libraries. So all these components are helping us in moving towards the serverless technology. So yeah, so here what I can say is we have learned a lot when we were moving from server to serverless technology. That is that first you need to have a clear roadmap for your project migration. So without this, if you think that, okay, I am moving into the serverless technology, it becomes very difficult. You need to have a clear understanding of your products. You need to have clear understanding of how you are going to migrate. You will also need to understand the problems which you are going to face in the serverless technology, which we are going to discuss soon in the next slide. So you also need to understand your core team strength, because initially, as I discussed, our core team strength was a PHP, Laravel, and if I directly want to go into the serverless, so you know what happens when we go into something which it's an unknown territory from directly from server to serverless. So we didn't want to do that. We wanted to upskill. So that is why you need to understand the strengths and weaknesses of your team, and then you decide whether you want to completely scrap off your team or you want to upskill them so that you enable them to develop the same projects with the new technology. You should also have a long-term vision on how you are supporting your existing products with the changes that are happening in the cloud technology, and also how new product requirements can affect the overall cloud services. Because once you are moving into the serverless technology, you might face an issue wherein some of the things may not be supported inside the serverless technology. Now, you need to have a clear understanding of what is getting supported, and if it is not getting supported, you need to understand how do I overcome with that the serverless technology. There are many communities out there where you can go and search about it, but make sure that have a clear idea on what all different types of projects which are coming up, and how am I moving to the serverless. You also need to understand overall company budget understanding and decision making, because when you are moving into the serverless, definitely it is going to reduce the price, but that doesn't mean the overall technology which your team has to be trained in, which your server team has to be trained in, which your developer team has to be trained in, that also come into the picture. So you have to take all these things into understanding before moving into the serverless. So let's try to understand the pros and cons of moving into server to serverless technology. So I would say upskilling, I would not say it is as a con, but I would rather say it is a time-taking process, right? So it is not going to be that, yeah, so today I looked into the serverless and I'm going to go. So developers need to be made sure that they understand the serverless technology works, because there is a clear division on when it comes to a project. There's a clear division on who is a developer and who is a server, who is the person who is looking into the servers. So there is a clear division in it. So when you are trying to make a developer into a serverless, when you are bringing him in the serverless world, you need to make sure that the developer also understands the things from the infrastructure point of view. You need to make them understand that you not only have to understand what is the feature that need to be developed, you also need to understand how it is going to be deployed on the server so that you will write a better code. So you have to bring down this huge gap which is there between the server team and the development team. That becomes more important. So when you are upskilling, you have to take these two teams and make sure that both are compatible with each other. And when it comes to hiring, you have to make certain decisions. So you can, when we started working on this, so when we are moving away from the PHP to the Node.js serverless frameworks, so then you have to make a decision that, okay, so now we are moving away from the serverless technology, our hiring method has to change. So what are the different types of hiring methods you have to change? Whenever you are hiring a developer, make sure that they also understand the cloud technologies. If they are only understanding from the development point of view, it becomes a little bit challenging. Eventually they are going to learn, but it becomes an important point when we are hiring anyone. Okay, so next, when it comes to maintenance, there will always be a production issues. And when I started myself, when I started doing the POCs and all, I understood that production issues is something bit of a difficult in the initial days when it comes to a serverless, because for a small projects or anything like that, it becomes a little bit easier to debug and fix the code. But there will always be a days wherein you will find some issue which on server, you will go on the server and run some code and you'll be able to get. But in terms of serverless technology, you need to do a lot more things. You need to understand the X-ray, you need to understand the cloud watchlogs, you need to understand the cloud trails. There are many more services which are provided. You should have a clear understanding of these things. Not only the cloud server team, your developer needs to have a clear understanding of these things. So make sure that when they are getting upskilled, that they are also getting the knowledge on the things which are like X-ray, cloud watchlogs, which are all maintenance tools. So yeah, so when we were moving to the serverless technology, we had a good and bad days. So it is not like everything was happy occasion. So definitely when we were moving, we had a days wherein we had a production issues where we could not understand where it was happening, why it was happening. We had to do a lot of digging. So these days will happen definitely, but we should not worry about that when we are going to serverless. Definitely those days will come and we have to be strong and we have to be moving forward because the end result is really good. So once we move past those bad days, we really started seeing really good days. So it is very important for you to get involved with the serverless community and have understanding of how serverless technology is progressing. So this becomes important when you are started using the serverless technology. So as far as the cost optimizations are concerned, we were able to reduce up to 30% of the cost, and it can still be reduced up to 50%. And yeah, so there is if you think from the way you are developing the projects, as the thing progresses, as your team gets more and more accustomed to the serverless technology, the more you will understand the serverless technology, the more optimization you can do. Initially, whatever you have developed and deployed as a serverless framework, it might still be giving you 20% optimization, maybe 30%. But in the serverless technology itself, when you are writing the Lambda functions, when you are using the serverless frameworks, when you're using the SAM, you need to understand how exactly the Lambda is working. So how much time it is taking for a particular function. So now you can divide those functions into different functions and you can reduce the time. So yeah, so this is how you are. You have to understand and move forward with the serverless technology. And yeah, so end of the day, the serverless technology is evolved enough nowadays to make sure that we can go without any worries. So even for the production level, any projects with the production level deployment with a huge number of customer base, I can definitely say that nowadays it is evolved enough to go, and we have done that, and we have some more projects which are still ongoing. So yeah, That's about the today's sessions. So yeah, so from the Whizlabs promotions, so we are providing a promotional code as a part of this event. So you can use this promotional code to get a 10% off on all the Whizlabs platform, any AWS courses inside the Whizlabs platform. It will be 10% off on top of whatever the discount we are providing. So yeah, make use of this. I think this will be available till 15th midnight. So till 15th midnight, this will be active. You can make use of it. Yeah, so one more important announcement before I say goodbye. So tomorrow I am also taking another workshop on AI ML. So this is a workshop in which you are going to learn how to train and develop and deploy a machine learning model, how AWS services can be leveraged to create the production-ready machine learning model. You will be using the Sagemaker instance, S3 bucket, API gateway, Lambda services. So we are going to do all these things practically, and Whizlabs is providing the platform for free for practicing these things. So you will get all the AWS account and services which you need for free. So make sure to register this. So these are the links. I think our organizers will also share this in our link somewhere in the chat. So please look for it and register for it. You will also be getting a lot of vouchers, goodies, and all the things which I have shared here, the t-shirts, the flask, all the goodies you will be getting. Yeah. Thank you so much. I am very happy to be part of this community day, and I thank Nipali and Sushit for making this possible. Thank you so much, guys. From being an attendee to being a speaker has been a really good job.
All right. That was an amazing journey, Pawan. It was very informative, and thank you so much for sharing your incredible experience with us. So let us see if there are any questions in the chat. Okay. So seems like there are no questions, but there is one thing that an attendee has mentioned. So Pawan mentioned if they handled observability or SRE in their migration journey. So how was was it handled?
Yes. Yeah, we did handle this observability. What we did is first we started with the backend services where we had all the framework which is running on the backend services with the Lambda code, and we did have statistically proven data wherein we could say that the functions which we were running properly without any issues. So there were situations wherein we faced an issue in terms of the bottlenecks of the Lambda in terms of number of concurrent Lambda which you can run. So those are the kind of the bottlenecks which we had. Yes, we did have a lot of statistics before moving further with this. Yeah.
Okay, great. And there is one question from my side. So how expensive was this migration in terms of time?
Okay. So in terms of because we had around 10 to 20 servers, different servers, and 10 to 20 different types of projects which we had. So we did divide them into different categories. So some of the projects which were very small, we were able to move them within a month or two. But some of the complex projects which were running, which had the LMS kind of a things, it took us 6 months to completely move away from the server to serverless technology because we had to develop hundreds of new APIs with the new Node.js technologies. We had to move away from the Laravel to the Node.js. So that is something where it took us a time for the complex. Otherwise, as far as the simple projects are concerned, it took us 1 or 2 months. But definitely, it all depends on the type of the project which you are building. And for the complex projects, mainly the challenges would be related to DB and backend services. So front end can be moved easily. So yeah.
All right, great. All right, so there we have another question. Homepage of Whizlabs today is developed in Amplify. Is it?
Yes, that is an ongoing process. Right now, it is not there in that. We are, as I said, it is the ongoing process. Right now, it is in the ECS, in the V3. And as I said, we are moving towards the Amplify. So some of the things which are already moved to Amplify, but not the Whizlabs homepage as of now. That will soon happen.
What are the advantages of using serverless over other architectures?
Okay. Serverless, in terms of using the serverless architecture, when it comes to the other architecture, in terms of, let's assume that there is a server architecture and then there is a serverless architecture. So what is the advantage? In terms of advantages, the server has to run 24/7, 365 days. You don't have to, even if a user is there or not, number of users are there or not, it has to always run. You will always have the cost to incur. In terms of serverless technology, the advantage is being pay as you go. So how much ever Lambda compute you are using, that much only you are paying. You are also making utilization of many other serverless services like S3. You are using the step functions, which becomes more important when you are developing a complex life cycle, because the step function is something which is helping us a lot in terms of designing a very complex life cycle type of functionalities which we are developing.
All right. Thank you so much, Pawan. That was very informative, and thank you so much for clearing our doubts. If there are any other questions, you can please log into YouTube and you can please answer them over the chat. And thanks again for joining with us today.
Thank you. Thank you so much. Thank you.
All right. So, people, I hope you enjoyed the session. So, we still have a quiz. So, please stay tuned. And there is a QR code that will be coming on the screen. All right. So, you can scan the QR code and you can join the quiz. And for the people who hasn't signed up yet to QuizHub, please sign up using the QR code or for the quiz link that is provided in the chat session. And also, people, the goodies are very good. We have we will be having top 10 winners. So please make sure everybody join the quiz. Sorry, top 20 winners. Okay, so I guess we can get started with the quiz. So here comes the first question on your screen. Which of the following is not true about AWS step functions? It provides basic primitives such as branching, parallel execution, and timeouts. Pay-as-you-go model. It is a serverless function orchestrator that makes it easier to sequence AWS Lambda functions. You can use it only for batch workflows and not event-driven workflows. Right? We already have a lot of participants answered it correctly. And right, the time is up. And wow, 58% of participants have answered it correctly. So the correct answer is you can use it only for batch workflows and not for event-driven workflows. So this is not true because AWS step functions is an orchestrator that makes it easy to sequence AWS Lambda functions and multiple AWS services into business-critical applications. Through its visual interface, you can create and run a series of checkpointed and event-driven workflows that maintain the application state. AWS Step Functions manages the logic of your application for you and implements basic primitives such as branching, parallel executions, and timeouts. All right, let's move on to the next question. And 3, 2, and 1. Which of the following is not an advantage of choreography model? No single point of failure. End-to-end monitoring reporting is relatively easy. Each step of flow can be scaled independently. Each step of flow can be changed independently. All right. So we have Harsh Mavi at the top and Muhammad Mujahid Ali at the third now, Adar Jogi at second again, and we have, the time is up. All right. Okay, so only 11% of participants were able to answer this correctly. Let's move on to the next question. And coming up now, RDS proxy is a complete substitute or replacement for your relational database. So you don't need to use any database when you use RDS proxy. True or false? All right. The top 20 winners. Let's see who get it. I see Mujahid Ali, Adar Jogi at the top again, Mujahid Ali at second, Surya Sen at third. Okay. 32% have answered it. 50% of participants have answered it correctly. RDS proxy is just a service that helps in better management of database connections instead of application directly connecting to the database. Hence, it is not a substitute of or replacement for your database. Let's move on to the last question for the quiz. Adar Jogi is leading. Muhammad Mujahid Ali is on second and Surya Deep Sen is on third. You write AWS step functions in which format? YAML, XML, Bison, JSON. Okay, we see a change in the leaderboard. Muhammad Mujahid Ali is, okay, he came to second, and Adar Jogi, that's a good race. Adar Jogi is on the first. Muhammad Mujahid Ali on the second. Aishwarya Sood and the third. I am seeing consistent playing by Aishwarya Sood. And let's see. Right, so 69% of participants answered it correctly. So the explanation, AWS step functions are written in JSON format or configurations. All right, that was the end of the quiz. Thank you so much for joining.
It was very insightful session followed by the quiz. Thank you, Tahir. And so for the last technical session in our track 2, we have Kavya for the day. So Kavya is a third-year student pursuing her bachelor's in computer science with specialization in machine learning and artificial intelligence. She has been a continuous learner and curious in learning new technologies. Kavya is a student ambassador for Microsoft in her college. She will be speaking about a simple text-to-speech serverless app using Amazon Polly and Amplify. Let us welcome her.
Yes, ma'am. Am I audible? Is my voice clear?
Yes, it's audible, Kavya.
First of all, welcome everyone for this ACD India 2022. And I'm really quite interested and very curious in delivering a talk on building a serverless text-to-speech application. Now let me introduce myself. I'm actually Kavya Shri AN, and I'm pursuing computer science engineering with specialization in machine learning and artificial intelligence. And now let's dive into the session. So the agenda for today is, let's see the overview, and next, under the concepts and services, let's have a look on understanding what exactly is text-to-speech. Then let's see about the Amazon Polly and what exactly serverless means, and about the AWS Lambda and Amplify service. And next, let's have a look about the architecture diagram, and let's go ahead with the steps of implementation part, and finally with a small demo, and let's wrap up with the key takeaways at the last. So let's start now. So first of all, this session actually talks about building a serverless application hosted on Amazon Amplify that transcribes text using the Amazon Polly. So first, now let's understand what exactly means text to speech and how popular it is nowadays in this modern world. So text to speech technology is evolving drastically as more and more business are incorporating speech software onto their websites, because in this digitalized modern world everyone is seeking the digital content. So obviously the text to speech technology grows drastically, and text to speech is an assistive technology that reads digital text aloud. It then scaters to a larger audience and improves overall accessibility and convenience. It is also symbolized by a voice icon on most of the web pages. As you can see in a lot of websites, you could see a speaker icon or a voice icon. So by hovering a mouse over there, you could, and if you click it over there, you could hear the digital content as a voice. So that's what is nothing but the text to speech technology. And it also helps users better understand the dialects and pronunciation and the overall content without losing focus. So it is very beneficial for the end users. And that's what is nothing but the text to speech technology means. And now let's see about the challenges of text to speech. Obviously the challenges include the pronunciation errors and some language barriers exist, and the audio quality issues doesn't meet up to the users expectations, and there may be some prosody issues. So these are the challenges of the text to speech technology. But the AWS provides a lot of services to overcome all these challenges by providing a better service with low cost. That is nothing but you can pay as you go model. By that way, you could use the services. Thus, you could use the service in low cost and also in the high quality with low latency. Now let's see the overview of what exactly is Amazon Polly for text to speech. Amazon Polly is a service that turns text into naturalistic speech and letting you create applications that talk and build new types of speech enabled solutions. The Polly's text to speech uses the advanced deep learning technologies to synthesize natural sounding human speech. So, building speech enabled applications that work in many different countries with dozens of lifelike voices across a broad set of languages. So, the key point here to note is that the lifelike voices. So, the opponent side, you could not feel the robot is speaking, but you could hear the lifelike human voice in the other end. And that's what is created from the Amazon Polly. And Amazon Polly can create the customer voice for a lot of organizations. So it is widely used in a lot of organizations and institutions to create the voice for the digital content nowadays. And that's what is nothing but about the Amazon Polly. And now let's see about the benefits of Polly. Polly is used in real-time streaming, and it just stores and redistributes the speech. So we could cache it and we can use it later. And it sounds very naturally, and we could customize and control the speech output. And also we could use it in the low cost and low latency, and as it comes under the cloud-based solution, we could scale it up and down. Thus auto scaling is very beneficial. And coming to the use cases, it is useful in content creation and for e-learning purpose and also for telephony. And these are the benefits of Polly. And now let's have a look on how the Amazon Polly works. So the Amazon Polly service input includes the text message as well as the voice ID from the end user. And the output of the Amazon Polly is the speech. That is nothing but the audio stream for the input which is given by the user. So for building this application, we opt AWS Lambda. So why do we use this? So the reason for AWS Lambda is it is serverless. Serverless in the sense we could auto scale, and thus auto hosting of the code is possible in the Amplify, and the code and managing data, and thus we can integrate the applications. Everything is done all without the managing services, and Lambda manages all the services and no manual work needs to be done, which is highly tedious. And the benefits of serverless include, as I have already said, it includes the auto scaling. This we can use the applications to meet up the customers, that is the end users need, that is with high quality and low latency. And we could follow that pay-as-you-go model to increase the agility, and thus we could optimize the cost as well. And by this serverless, we could thus deploy it quickly, and updates are also possible to get faster by using this serverless technology. And next, this is what the architecture diagram of connecting the Poly as well as the Amplify. So you could here see the browser app. So the user just gives the input text to the browser app, which is served from the Amplify. And I'm using the API gateway as well as the Lambda function. The API gateway triggers a Lambda function. The Lambda function, which in turn talks to the Amazon Poly as well as the S3 bucket. And finally, we'll be getting the signed URL from the S3 bucket, which the users can access it from the front end later from the Amplify service. So this is what the architecture of connecting the Poly as well as the Amplify. And next, coming to the steps of implementation, as I've already said, the input text is given by the user through the browser app, and the browser app is served from the Amplify. The source code of the Amplify resides in the S3 bucket, and the user clicks the post request, which is nothing but the /speak, and thus the connection to the API gateway is met out, and the API gateway then triggers the Lambda function. The Lambda gives the text-to-speech request to the Poly service, and the output from the Poly is the audio stream, which is nothing but the output stream for the corresponding input text, which is given by the user, and it is finally uploaded in the S3 bucket, and it is also done by the Lambda function. So after we just upload the audio stream, which is retrieved from the Poly in the desired format for the user, we then take the specific URL of that S3 bucket, that is the signed URL, because it lasts only for few minutes and just expires. So that signed URL can be accessed from the Amplify, and then later the end user can play the audio in the browser. And this is what is nothing but these are the steps under the implementation part. And now coming to linking the Poly as well as the S3. So initially we need AWS SDK. So we download a copy of the SDK and integrate it in your application or the website. And next we need an IAM user. So one with access to the Poly, because the Lambda function talks to both the Poly API as well as the S3 API. So the IAM role must be specified with the access key ID as well as the secret key for that user. And with SSML honor of type, we could give the input text, and we could choose the language, region, and voice of the text based on the desire of the end user. And then we have to choose save to S3, and the console opens to store the output file. And we have to fill the destination Amazon S3 bucket, and optionally the prefix key can also be given. And the source code of the Amplify resides in the S3 bucket. Later, the API gateway triggers the Lambda function, and the Lambda gives the text-to-speech request to the Amazon Poly. Thus, it could be connected. And this is what is nothing comes under linking the Poly and S3. And next, let's see how we can deploy the serverless web app using the Amazon Amplify. AWS Amplify, as we all know, is a set of tools and services that can be used together or on their own to help the front-end web and mobile developers build scalable full-stack applications. So AWS Amplify, through this service, we could handle the full-stack applications, that is both the front-end as well as the back-end. So with the Amplify, we can configure app backends and connect the app in just few minutes, and we could deploy the static web apps in few clicks and easily manage the app content outside the AWS console. So here we run sound from the S3 sound file from the S3 bucket to the browser application served from the Amplify. So what I like to say here is that we could access the signed URL of the output MP3 file for the corresponding input text in the browser application using the Amazon Amplify service. And next, coming back to accessing Poly from Amplify. So first we have to import the existing S3 bucket URL into the Amplify console, and we have to get started by running the Amplify import storage to search for, and the API gateway that triggers the Lambda function, and the Lambda gives the text-to-speech request to the Amazon Poly as well, and the output of the Poly is that is the audio stream, and is uploaded in the S3 by the Lambda. And later we could take the URL of the S3 bucket and run the Amplify push to complete those import process, and later we could deploy. So the thing here is we have to configure the IAM role to use the Amplify recommended policies. Hence, you can access the content of the poly from S3 in the static website by the Amazon Amplify. And this is what comes under the accessing poly from the Amplify. So now let me show you all a small demo. I hope my screen is visible. And this is what the SDK by which we are going to access the poly service. You could see here the synthesized speech API and a lot of API functions under the Amazon Amplify. So this synthesized speech method has the input text as well as the voice ID as the input from the end user. It gets the input as the input text as well as the voice ID, and later it just triggers the API gateway, then triggers the Lambda function, which in turn talks to the poly service as well as the S3 API. And that's what is the key theme of my application. And later, this is the console of the AWS, and here a lot of services is mentioned, but under machine learning you could see a lot of services too. In machine learning, you could see the Amazon. Under machine learning, you could see the Amazon Poly. The reason for Amazon Poly under machine learning is that because it uses the deep learning technologies, so that it comes under the machine learning service. So this is what I have told you already. The Amazon Poly is a service that turns text into a lifelike speech. That's what the key notion of this service. And thus we could turn the text into a lifelike speech by using the Amazon Poly. And now let's see the steps of implementation. I'll just show you my GitHub repository. So first we have to create a serverless project. Actually, this application includes both the front end as well as the back end. So we have to use a serverless framework. So to install it, we have to just type npm install services -g in our integrated terminal. And I have done all this just to share you the insights and just giving the overall glimpse of the steps of implementation. And later, after just installing this, we have to then create a project. In my sense, I have created a project named backend under the AWS Node.js. So this must also be given under the integrated terminal. And after just giving all these two commands, you will be getting two files. I'll just show you in the VS Code. So you'll be getting a handler.js as well as the serverless.yml file. And under serverless.yml, actually this is a main file where the configuration details tends to appear here. So the service name, that is my project name, is talking backend, and the provider details are the runtime, as well as I'm using the region or the resource. I'm using the region of US East. That is, I'm accessing all the resources under the US East. And this is the IAM ARN policy role. And this is what under the functions you could see the Lambda function call, which is nothing but handler.speak. And under events, you could see the HTTP path, which is nothing but the API gateway. So the API gateway triggers the Lambda function. So the gateway is called here under this events. And I'm giving the CORS as true to connect all the regions. And this is what my serverless.yml file which is created. And then after this, we have to create a S3 bucket to store the content. the S3 bucket name must be unique, and so we have to take care of it. After creating the S3 bucket, we have to create a IAM role, because we have to set the access permissions, as it is very vital. Why? Because means it has to talk to both the Poly API as well as the S3 API. So it is better to give the IAM role. So this is a snippet of code from the visual editor of the IAM, which I have already tried myself. And here there are two statements. So from this snippet of code, under these two statements, we could infer that under action, first it is given as poly star. What it means is that we could understand the lambda function could able to get all the poly services, and later it can also get access to all the S3 API services too. That's what is nothing but these two statements which comes under the creating IAM role policy. And after just creating this, you'll be getting an ARN policy, that is the link. You have to paste that ARN policy here under the role section, and this is what is nothing but a serverless YML file. After this, we have to proceed with a speak lambda function. So the main three tasks under the speak lambda function is that initially we have to call that speech API and get the audio stream for the text that user entered, and later we have to store that audio stream in the S3 bucket, and later after storing the audio stream from to the S3 bucket, we have to get the signed URL of the saved MP3 in the S3, and it can be accessed from the front end application by the end users. So that's why we have to create the lambda function. So I'll just show you the lambda function here, and this is what I have copied from my lambda function console. So here, as I've already mentioned, under the require method, we are passing the parameters as AWS SDK, and we are just using the speak function, and under that we are having a body attribute. So under that, we are just giving the input text as well as the voice ID, which must be given as the input for the Amazon Poly under the object name Poly params. And later we have to then get the audio stream for the text that user entered. So for that, I'm for getting back the audio stream, I have to create a bucket name, and the format of the bucket can also be given. In my side, I'm just giving us MP3, and the body of the content is the audio stream. And later, I'm just using the put objects function and gathering all the content. And later, after getting all those kind of stuff, I'm just creating getting a signed URL for the saved MP3 file. For that, I'm using the get signed URL function. And later, this URL function can be accessed from the front end Amplify, and that's why that's how we could access the text content which we are giving as the input uh, to the end users. And this is how the application runs, and thus the AWS services are used here. And so by leveraging the AWS services, we could achieve here the high quality, low latency, as well as it is very user friendly for the users to access. And that's what I wish to say that. And now, at last, now coming to the main key takeaways. Thus, from this, we could leverage the power of machine learning in text-to-speech, mainly by using the Amazon Poly as well as the Amazon Amplify. And we could understand how to store the Amazon Poly, that is output stream, to the S3 bucket. And later, we are just retrieving the content of the MP3 file as a signed URL from the S3 bucket, and we are accessing it from the front end by the Amazon Amplify service. And that's all for my content. And thank you.
Thank you so much, Kavya, for this wonderful session. So we have a few questions lined up for you.
Yes, ma'am.
You can turn your audio, video on as well. It's fine. Yes. Can Poly be configured to use a custom human-like voice, or can we only select from a present choice of human voices?
It can be custom into a lot of options, but till now we just have a few options. But as far as organizations are concerned, they could customize it the way they want.
Okay. Yes. And we have another question from the same person.
Yes, ma'am.
Is Amplify some kind of a near substitute for CloudFront, which can also serve content from S3?
Yes, ma'am, exactly. And it can handle both the front end as well as the back end, thus giving a good application for the full stack creation.
Okay. Yeah, I think only two questions. And please join the YouTube stream, and also you can comment the queries from there itself. I
Thank
thank
you,
you so
ma'am.
much, Kavya.
Thank you, ma'am.
Okay, so let's have it quiz for the session. So we'll be giving a 2-minute break. So whoever haven't signed up into the quiz hub, they can sign up and play the quiz. The link for the quiz is pasted in the comment box, and also you can scan through the QR code. So this will be the last quiz for the track 2. Yes, we have overall 242 participants. Let me see someone else also joins in. Okay. Yes, let us start our last quiz for the day. So, yeah, I have started the quiz, and you will be able to see the first question on your screens. What is the role of Amazon Poly? Convert text to speech, convert speech to text, both or none? Now I can see most of the people have answered already. The quiz will be, the scores will be based on the correct answer as well as the time. So please be fast and answer the question. Yes, the first question have been ended. Let's see the stats. Okay, 53% of the participants have attempted the right answer. Yes, let's go for the next question. What exactly is Amazon Amplify used for? To send email notifications, build and host full stack application, to handle only front end, to handle only back end. So, there's so many people already answered the question, and we have Aditya Avati on the top. It's please fasten up. It's we are done with the question too, and let me check. Okay, it's nice. Like 74% of the participants have answered the right option. Let us jump for the next question. Yes, the third question is, what is true about signed URL in AWS? Signed URL doesn't exist. Allow user to download or stream the content. The URL expires after a while. Both B and C. Now Sagnik is on the top with 3 points, followed by Tanvi and Vandana. The last question decides who wins the leaderboard of this respective quiz. And 55% of the people have opted the correct answer. Now let's move on to our last question. Okay, which service provides serverless computing? AWS Lambda, AWS AppSync, AWS Athena, all of the above. Sagnik is on top, Tanvi is having in second position, Vandana is having in third position. Yes, let us see the stats. Okay, like 53% of you have opted for the right answer. That's great. And yeah, let's end the quiz. So we came to the last of the track 2, and I hope all the sessions today were extremely valuable for everyone who attended the sessions. And I do want to thank you all for engaging with us in the chat. We love to see you all to be a part of this community. Tomorrow we are having the workshops, so please do register and grab the seat. You can register from AWS Community website. That will be linked in the comment section below. And the winners of the tournament will be also announced in track 1. So the technical day haven't ended yet. Please do join track 1 for the session coming up. Thank you.
Also, people, there are wonderful goodies for workshops. So please do attend and gain the most from it. Thank you so much. Thank you so much for joining, everyone.
Yeah, we'll be also pasting the link for the track 1 in the chat box. Thank you, everyone.